Okay, so good morning, everybody. I hope my audio is audible and there is no issue from the audio side. So today we will be dealing with the chapter that is second PUC chemistry, that is solutions chapter, which is physical chemistry part. This is chapter 1 as per the new syllabus. So let me tell you that this is a very important chapter where you need to understand what are the formulas used for competitive examinations, what are the types of concentration terms that you apply in order to solve the questions. All these you need to know. So let's just start from the basics and go up to the expressing concentrations. So first of all, starting with the simple word that is a chapter name, that is solutions. You must have heard about this word a lot of times in your daily life, saying, you talk about sugar solution maybe. Sugar solution andre ನಾವು ನೀರಲ್ಲಿ ಒಂಚೂರು ಶುಗರ್ ಹಾಕಿ ಮಿಕ್ಸ್ ಮಾಡಿದ್ರೆ ಯು ಕಾಲ್ ಇಟ್ ಶುಗರ್ ಸೊಲ್ಯೂಷನ್ ಅಂತ ಹೇಳ್ತೇವೆ. ಅಂದ್ರೆ ಒಂದು ಒಂದು ಸಣ್ಣ ಅಮೌಂಟ್ ಇದು ಸಬ್ಸ್ಟೆನ್ಸ್ ಅನ್ನು ನಾವು ದೊಡ್ಡ ಅಮೌಂಟ್ ಇದು ಸಬ್ಸ್ಟೆನ್ಸ್ ಗೆ ಹಾಕಿ ಅದನ್ನೊಂದು ಹೋಮೋಜಿನಸ್ ಮಿಕ್ಸ್ಚರ್ ತರ ಮಾಡಿದ್ರೆ ಯು ಕಾಲ್ ಇಟ್ ಅ ಸೊಲ್ಯೂಷನ್. ಫಸ್ಟ್ ಆಫ್ ಆಲ್ ಒಂದು ವರ್ಡ್ ಯೂಸ್ ಮಾಡಿದೆ, ದಟ್ ಇಸ್ ಹೋಮೋಜಿನಸ್ ಅಂತ. ಹೋಮೋಜಿನಸ್ ಮಿಕ್ಸ್ಚರ್ ಅಂತ ಯೂಸ್ ಮಾಡಿದ್ದೇವೆ. ಸೊ ಹೋಮೋಜಿನಸ್ ಅಂದ್ರೆ ಏನು? ನೀವು ಶುಗರ್ ಅದನ್ನು ನೀರಿಗೆ ಹಾಕಿ ಡಿಸಾಲ್ವ್ ಮಾಡಿದಾಗ you see that sugar does not stand as it is. After some time, it is going to dissolve. You don't find the sugar back again, which means it has completely gone into the spaces between water molecules. Anta heluvaga you use the word homogeneous solution. Andre you don't find it in a separate layer. Whereas when you talk about heterogeneous, for example, you must have studied in school saying it is oil and water. Oil and water ಹಾಕಿದಾಗ ಏನಾಗ್ತದೆ, ಅದು ಲೇಯರ್ಸ್ ಆಗಿ ನಿಲ್ತದೆ. ಅದನ್ನು ಹೇಳುದು ಹೆಟ್ರೋಜಿನಸ್ ಮಿಕ್ಸ್ಚರ್ ಅಂತ. ಹಾಗಾದ್ರೆ ಹೋಮೋಜಿನಸ್ ಅಂದ್ರೆ ಯು ಡೋಂಟ್ ಫೈಂಡ್ ದ ಸೊಲ್ಯೂಟ್ ಬ್ಯಾಕ್ ಅಗೇನ್. ಅಥವಾ ನೀವು ಯಾವುದೇ ವಸ್ತು ಅಥವಾ ಪದಾರ್ಥವನ್ನು ಸಾಲ್ವೆಂಟ್ ಗೆ ಹಾಕಿದಾಗ ಅಥವಾ ನೀರಿಗೆ ಹಾಕಿದಾಗ ಯು ಡೋಂಟ್ ಫೈಂಡ್ ದಮ್ ಎನಿಮೋರ್. ಅದಕ್ಕೆ ಹೇಳುದು ನಾವು ಹೋಮೋಜಿನಸ್ ಸೊಲ್ಯೂಷನ್. ಓಕೆ, ದೊಡ್ಡ ಕಾಂಪ್ಲೆಕ್ಸ್ ವರ್ಡ್ ಎಲ್ಲ ಯೂಸ್ ಮಾಡ್ತಿದ್ವಿ, ಬಟ್ ಇಟ್ಸ್ ಆಕ್ಚುಲಿ ಸಿಂಪಲ್. ಓಕೆ, ಸೊ ಫಸ್ಟ್ ಆಫ್ ಆಲ್ ಐ ಟೋಲ್ಡ್ ಯು ಸೊಲ್ಯೂಷನ್. ಅದಕ್ಕೆ ಎಕ್ಸಾಂಪಲ್ ಕೊಟ್ಟದ್ದು ಶುಗರ್ ಸೊಲ್ಯೂಷನ್. ಅದರಲ್ಲಿ ನಿಮ್ಗೆ ಎರಡು ಕಾಂಪೋನೆಂಟ್ಸ್ ಗೊತ್ತಾಯ್ತು. ಒನ್ ವಾಸ್ ಶುಗರ್ ಅಂಡ್ ದಿ ಅದರ್ ಒನ್ ವಾಸ್ ವಾಟರ್. ಕರೆಕ್ಟ್? ಶುಗರ್ ಅಂಡ್ ವಾಟರ್ ಗಾಟ್ ಡಿಸಾಲ್ವ್ಡ್. ಸೊ ಇದಕ್ಕೆ ನಾವು ಎನಿಮೋರ್ ಯೂಸ್ ಮಾಡುವಾಗ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಸಿ ಡಿಫರೆಂಟ್ ಟೈಪ್ಸ್ ಆಫ್ ಸೊಲ್ಯೂಷನ್. ಸೊ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಯೂಸ್ ಅ ಟರ್ಮ್. ಆ ಶುಗರ್ ಲೆಸ್ ಕ್ವಾಂಟಿಟಿಯಲ್ಲಿ ಇದ್ದದ್ದು, ಲೆಸ್ ಕ್ವಾಂಟಿಟಿ ಅಂತ ಹೇಳುವಾಗ ಯು ಕಾಲ್ ದೆಮ್ ಆಸ್ ಸೊಲ್ಯೂಟ್ ಪಾರ್ಟಿಕಲ್ ಅಂತ. ಸೊಲ್ಯೂಟ್ ಪಾರ್ಟಿಕಲ್. ಓಕೆ, ಅದೇ ಇನ್ನೊಂದು ಪದಾರ್ಥ ಏನದದು, ದಟ್ ಇಸ್ ವಾಟರ್. ವಾಟರ್ ಅನ್ನು ವಿ ಕಾಲ್ ಇಟ್ ಆಸ್ ಸಾಲ್ವೆಂಟ್. ಸೊ ಹೌ ಡು ಯು ಐಡೆಂಟಿಫೈ? ಈಗ ನಾವು ಸಾಲ್ಟ್ ಸೊಲ್ಯೂಷನ್ ಕೊಟ್ರೆ ಇಮ್ಯಾಜಿನ್, ಜಸ್ಟ್ ವೇರಿಯೇಷನ್. ಬಟ್ ಅದರಲ್ಲಿ ಹೇಗೆ ನಾವು ಐಡೆಂಟಿಫೈ ಮಾಡುದು ವಿಚ್ ಇಸ್ ಸೊಲ್ಯೂಟ್ ಅಂಡ್ ವಿಚ್ ಇಸ್ ಸಾಲ್ವೆಂಟ್? ಅಗೇನ್ ದ ಸ್ಮಾಲರ್ ಕ್ವಾಂಟಿಟಿ ಒನ್ ವಿಲ್ ಬಿ ದ ಸೊಲ್ಯೂಟ್, ದ ಲಾರ್ಜರ್ ಕ್ವಾಂಟಿಟಿ ಒನ್ ವಿಲ್ ಬಿ ಆಲ್ವೇಸ್ ಸಾಲ್ವೆಂಟ್. ಅಗೇನ್ salt will be solute, the larger quantity one was water, that is called solvent. When you add up solute and solvent together, it's going to make up a solution. Simple. ಈ ಒಂದು ಸ್ಲೈಡ್ ಅಲ್ಲಿ ಎರಡೇ ಟರ್ಮ್ಸ್, ಒನ್ ಇಸ್ ಸೊಲ್ಯೂಟ್ ಅಂಡ್ ದಿ ಅದರ್ ಒನ್ ಇಸ್ ಸಾಲ್ವೆಂಟ್. ಚಿಕ್ಕ ಮಾತ್ರದಲ್ಲಿ ಹಾಕಿದ್ರೆ ಯು ಕಾಲ್ ಇಟ್ ಸೊಲ್ಯೂಟ್, ಲಾರ್ಜ್ ಅಮೌಂಟ್ ಅಲ್ಲಿ ಹಾಕಿದ್ರೆ ಯು ಕಾಲ್ ಇಟ್ ಸಾಲ್ವೆಂಟ್. ಟುಗೆದರ್ ಯು ಪುಟ್ ಇಟ್, ಮೇಕ್ ಅ ಹೋಮೋಜಿನಸ್ ಮಿಕ್ಸ್ಚರ್, ದೆನ್ ಯು ಕಾಲ್ ಇಟ್ ಅ ಸೊಲ್ಯೂಷನ್. ಅಷ್ಟೇ. ಮೂವಿಂಗ್ ಆನ್. ಸೊ ಸೊಲ್ಯೂಷನ್ ನೀವು ನೋಡಿದ್ರೆ ಇಟ್ಸ್ ಅ ಹೋಮೋಜಿನಸ್ ಮಿಕ್ಸ್ಚರ್, ಆಲ್ರೆಡಿ ಹೇಳಿ ಆಯ್ತು. ಸೊಲ್ಯೂಟ್ ಅಂದ್ರೆ ಇಟ್ ಇಸ್ ದ ಒನ್ ವಿಚ್ ಇಸ್ ಪ್ರೆಸೆಂಟ್ ಇನ್ ಲೆಸ್ಸರ್ ಅಮೌಂಟ್. ಓಕೆ, ಲೆಸ್ಸರ್ ಅಮೌಂಟ್, ದಟ್ ಇಸ್ ವೇರ್ ಯು ಆರ್ ಗೋಯಿಂಗ್ ಟು ಚೆಕ್. ಅಂಡ್ ಸಾಲ್ವೆಂಟ್ ವಿಲ್ ಬಿ ದ ಒನ್ ವಿಚ್ ಇಸ್ ಪ್ರೆಸೆಂಟ್ ಇನ್ ಲಾರ್ಜರ್ ಅಮೌಂಟ್. ಅದು ಗೊತ್ತಾಯ್ತು. ಟೈಪ್ಸ್ ಆಫ್ ಸೊಲ್ಯೂಷನ್ಸ್ ನೋಡೋಣ. ವಾಟ್ ಇಸ್ ಟೈಪ್ಸ್ ಆಫ್ ಸೊಲ್ಯೂಷನ್ಸ್? ಸೊ ಈಗ ನಾವು ಹೇಳ್ತೇವೆ ಸೊಲ್ಯೂಷನ್ ಅಂದ್ರೆ ನೀರಲ್ಲೇ ಕಲಡಿಸ್ಬೇಕು ನಾವು, ನಥಿಂಗ್ ಎಲ್ಸ್ ವಿ ಕ್ಯಾನ್ ಯೂಸ್ ಅಂತ. ಬಟ್ ಆಗಲ್ಲ. you can make use of some other solution. ಅಂದ್ರೆ ನೀವು ಈ ನಮ್ಮ ಸ್ಕೂಲ್ಸ್ ಅಲ್ಲಿ ಎಲ್ಲ ಬೆಲ್ ಅನ್ನು ನೋಡಿರಬಹುದು. ಬೆಲ್ ಇಸ್ ಮೇಡ್ ಅಪ್ ಆಫ್ ಸಮಥಿಂಗ್ ಕಾಲ್ಡ್ brass is an alloy, you must have studied. Alloy is again a homogeneous mixture. ಅಲ್ಲಿಯೂ ಆ ವರ್ಡ್ ಬರ್ತದೆ, homogeneous mixture of two or more metals or a metal and a non-metal. ಸೊ ಬ್ರಾಸ್ ಅಲ್ಲಿ ಯೂಸ್ ಮಾಡುದು ನಾವು ಮೆಟಲ್ಸ್ ಯಾವುದು, ಕಾಪರ್ ಮತ್ತೆ ಜಿಂಕ್ ಅಂತ ಯೂಸ್ ಮಾಡ್ತೇವೆ. ಕಾಪರ್ ಮತ್ತೆ ಜಿಂಕ್ ನಾವು ಏನು ಸಪರೇಟ್ ಲೇಯರ್ಸ್ ಅಲ್ಲಿ ಫೈಂಡ್ ಮಾಡುದಿಲ್ಲಲ್ಲ, ಅದನ್ನು ನಾವು ಮಿಕ್ಸ್ಚರ್ ತರ, ಅದೊಂದು ಹೋಮೋಜಿನಸ್ ಮಿಕ್ಸ್ಚರ್ ಆಗಿದೆ. ಎರಡೂ ಮಾತ್ರಗಳನ್ನು ಈಕ್ವಲ್ ಅಮೌಂಟ್ ಅಲ್ಲಿ ದೇ ಹ್ಯಾವ್ ಗಾನ್ ಇನ್ ಟು ದ ಸ್ಪೇಸಸ್ ಬಿಟ್ವೀನ್ ಈಚ್ ಅದರ್. ಸೊ ಯು ಕಾಲ್ ಇಟ್ ಅ ಹೋಮೋಜಿನಸ್ ಮಿಕ್ಸ್ಚರ್. ಸೊ ಅದು ಸೇರಿ ಒಂದು ಕಂಪೌಂಡ್ ಆಗಿದೆ, ದಟ್ ಇಸ್ ಕಾಲ್ಡ್ ಬ್ರಾಸ್, ಆರ್ ಅನ್ alloy has formed, that is called brass. ಸೊ ಅದಕ್ಕೆ ಹೇಳುದು ಸೊಲ್ಯೂಷನ್ ನಾವು ನೀರೇ ಯೂಸ್ ಮಾಡ್ಬೇಕು ಅಂತ ಇಲ್ಲ. ಇಟ್ ಕ್ಯಾನ್ ಬಿ ಸಾಲಿಡ್ ವಿತ್ ಸಾಲಿಡ್ ಆಲ್ಸೋ. ಮೇ ಇಟ್ ಬಿ ಸಿಂಪಲ್. ನೀವು ನಿಮ್ಮ ಏರ್ ಅನ್ನೇ ತಕೊಳ್ಳಿ, ಗಾಳಿಯನ್ನೇ ತಕೊಳ್ಳಿ, ದರ್ ಇಸ್ ಆಕ್ಸಿಜನ್, ದರ್ ಇಸ್ ನೈಟ್ರೋಜನ್, ದರ್ ಇಸ್ ಕಾರ್ಬನ್ ಡೈಆಕ್ಸೈಡ್, ಡಸ್ಟ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಎಲ್ಲ ಸೇರಿ ನೀವೇನು ಸಪರೇಟ್ ಆಗಿ ಬ್ರೀದ್ ಮಾಡಲ್ಲ. ಆಕ್ಸಿಜನ್ ಒಂದು ಲೇಯರ್ ಬ್ರೀದ್ ಮಾಡ್ತೀರಾ, ಕಾರ್ಬನ್ ಡೈಆಕ್ಸೈಡ್ ನೋ, ಇಟ್ಸ್ ಅ ಮಿಕ್ಸ್ಚರ್ ಆಫ್ ಆಲ್ ಆಫ್ ದಮ್. ದಟ್ಸ್ ವೈ ಯು ಕಾಲ್ ಇಟ್ ಹೋಮೋಜಿನಸ್. ಸೊ ಯಾವುದೇ ಸೊಲ್ಯೂಷನ್ ಅಂತ ಹೇಳುವಾಗ ಇಟ್ ನೀಡ್ ನಾಟ್ ಬಿ ಆಲ್ವೇಸ್ ಲಿಕ್ವಿಡ್ ಓನ್ಲಿ. ಇಟ್ ಕ್ಯಾನ್ ಬಿ ಸಾಲಿಡ್ ಇನ್ ಸಾಲಿಡ್ ಆಲ್ಸೋ, gas in a solid also, gas in a gas also, solid and solid. ಅದಕ್ಕೆ ಎಕ್ಸಾಂಪಲ್ ಕೊಟ್ಟದ್ದು ಬ್ರಾಸ್. ಸೊ it can be different types of solution. Solution is a main branch, but need not be liquid. It can be applied to any of the states. ಅದನ್ನ ಹೇಳುದು solution. So ಅದಕ್ಕೆ ಹೇಳುದು we have types of solutions. So based on their nature of the solute, nature of solute, ಅದು ಎಷ್ಟು ಮಾತ್ರದಲ್ಲಿ dissolve ಆಗ್ತದೆ, solvent. Solutions are being classified into 3 types. Again, gaseous solutions you have, liquid solutions you have, and the last one is solid solutions. 3 types of solutions you have. Just a minute, let me just show you the list of salts. One second. I will just show you the list of salts. May it be, the solution, different types of solutions you're talking about. The first one is typically called gaseous solutions. You can see here, gaseous solutions in the head. So how to identify what is a gaseous solution? First of all, we told large quantity ನಾವು ತೆಗಿತೇವೆ, that is called solvent ಅಂತ ಹೇಳಿದ್ವಿ. ಸೊ ಗ್ಯಾಸ್ ಅಲ್ಲಿ ಏನಾದ್ರು ಈಗ ದೊಡ್ಡ ಅಮೌಂಟ್ ಗ್ಯಾಸ್ ಇದೆ, ಅದ್ರಲ್ಲಿ ಏನಾದ್ರು ಚಿಕ್ಕ ಅಮೌಂಟ್ ಆಫ್ ಗ್ಯಾಸ್ ಅನ್ನು ಹಾಕಿದ್ರೆ ನಮ್ಮ ಮೇನ್ ನೇಚರ್ ಹೇಗಿರುತ್ತೆ, ಗ್ಯಾಸ್ ಆಗೇ ಇರ್ತದಲ್ಲ. ಅದೇನು ಲಿಕ್ವಿಡ್ ಗೆ ಕನ್ವರ್ಟ್ ಆಗ್ಲಿಲ್ಲ ಅಥವಾ ಸಾಲಿಡ್ ಗೆ ಕನ್ವರ್ಟ್ ಆಗ್ಲಿಲ್ಲ. ಸೊ ಸಾಲ್ವೆಂಟ್ ಏನು ಗೇಷಿಯಸ್ ಮಾತ್ರದಲ್ಲಿ ಇದೆ. ಸೊ ಯು ಕಾಲ್ ಇಟ್ ಅ ಗೇಷಿಯಸ್ ಸೊಲ್ಯೂಷನ್. ಸಾಲ್ವೆಂಟ್ ಅನ್ನ ನೋಡ್ಬೇಕು ನಾವು ಯಾವಾಗಲೂ. ಈಗ ಸಪೋಸ್ ನನ್ನ ಸಾಲ್ವೆಂಟ್ ಲಿಕ್ವಿಡ್ ಅಲ್ಲಿ ಇದೆ, ಲಿಕ್ವಿಡ್ ಸ್ಟೇಟ್ ಅಲ್ಲಿ ಇದೆ ಇಮ್ಯಾಜಿನ್, ದೆನ್ ಯು ಕಾಲ್ ಇಟ್ ಅ ಲಿಕ್ವಿಡ್ ಸೊಲ್ಯೂಷನ್. ನನ್ನ ಫುಲ್ ಸೊಲ್ಯೂಷನ್ ಈಗ ಸಾಲಿಡ್ ಆಗಿದೆ ಅಥವಾ ಅದರ ಫಿಸಿಕಲ್ ಸ್ಟೇಟ್ ಇಸ್ ಸಾಲಿಡ್, ದೆನ್ ಐ ಕಾಲ್ ಇಟ್ ಸಾಲಿಡ್ ಸೊಲ್ಯೂಷನ್. ಇನ್ನು ಅರ್ಥ ಆಗ್ತದೆ ನಿಮ್ಗೆ. ಸಪೋಸ್ ದೊಡ್ಡ ಮಾತ್ರದಲ್ಲಿ, ಸಪೋಸ್ ಐ ಟೇಕ್ ಅ ಬೀಕರ್ ಇಮ್ಯಾಜಿನ್, ಇದರಲ್ಲಿ ದೊಡ್ಡ ಮಾತ್ರದಲ್ಲಿ ಗ್ಯಾಸೇ ಇದೆ. ಓಕೆ, ಅದರಲ್ಲಿ ಒಂಚೂರು ಗ್ಯಾಸ್ ಮಿಕ್ಸ್ ಮಾಡ್ತೀನಿ. Okay, so what is a physical state of this particular solution? It is still in gas only, no? That's why I call it gaseous solution. ಅದಕ್ಕೆ ಎಕ್ಸಾಂಪಲ್ ನೋಡಿ. ನೈಟ್ರೋಜನ್ ಜಾಸ್ತಿ ತೆಗೆದು ನಾನು ಆಕ್ಸಿಜನ್ ಚೂರು ಡಿಸಾಲ್ವ್ ಮಾಡಿದ್ರು ದೊಡ್ಡ ಫರಕ್ ಇಲ್ಲ, ಇಟ್ಸ್ ಸ್ಟಿಲ್ ಅ ಗೇಷಿಯಸ್ ಸೊಲ್ಯೂಷನ್. ಸೇಮ್ ವೇ ನಾನು ಗ್ಯಾಸಿಗೆ ಇನ್ನೊಂದು ಲಿಕ್ವಿಡ್ ಕ್ಲೋರೋಫಾರ್ಮ್ ಅನ್ನು ಮಿಕ್ಸ್ ಮಾಡಿದ್ರೆ it's again a large amount of gas with a little bit of chloroform added, it's again going to be a gaseous solution. ಅದರಲ್ಲಿ ಪುನಃ ಗ್ಯಾಸ್ ಅನ್ನ ಇಟ್ಟು ಒಂಚೂರು ಸಾಲಿಡ್ ಅದಕ್ಕೆ ಹಾಕ್ತೀನಿ. ಯಾವ ಸಾಲಿಡ್ ಯೂಸ್ ಮಾಡಿದೀವಿ ನಾವು? ಕ್ಯಾಂಫರ್ ಇಸ್ ಅ ಸಬ್ಲಿಮೇಬಲ್ ಸಬ್ಸ್ಟೆನ್ಸಸ್ ಅಂತ ಕೇಳಿದೀವಿ. ಸಬ್ಲಿಮೇಬಲ್ ಅಂದ್ರೆ ಇಟ್ ಕ್ಯಾನ್ ಚೇಂಜ್ ಇಟ್ ಸ್ಟೇಟ್ ಫ್ರಮ್ ಸಾಲಿಡ್ ಸ್ಟೇಟ್ ಟು ಸೀದಾ ಗೇಷಿಯಸ್ ಸ್ಟೇಟ್. ಇಟ್ ಡಸ್ ನಾಟ್ ಕಮ್ ಇನ್ ಟು ಲಿಕ್ವಿಡ್ ಸ್ಟೇಟ್. ಸೊ ಅಂತ ಒಂದು ಸೊಲ್ಯೂಷನ್ಗೂ ನಾವು ಗೇಷಿಯಸ್ ಸೊಲ್ಯೂಷನ್. ನಿಮ್ಮ ಮೇನ್ ಏಮ್ ಇಸ್ ಟು ಚೆಕ್ what is there in large quantity. Large quantity ಅಲ್ಲಿ ಯಾವುದೇ ಇರುತ್ತೆ, that becomes gaseous solution. Okay. Next, you talk about liquid solutions. We will see quickly. Liquid ಜಾಸ್ತಿ ಮಾತ್ರ ಲಿಕ್ವಿಡ್ ಇರಬೇಕು. ಬೆಸ್ಟ್ ಎಕ್ಸಾಂಪಲ್ sea water. Sea water ಅಲ್ಲಿ ಫಿಶಸ್ ಇರುತ್ತೆ. ಫಿಶಸ್ ಹೇಗೆ ಬ್ರೀದ್ ಮಾಡೋದು? ಒಂಚೂರು ಅಮೌಂಟ್ ಆಫ್ ಆಕ್ಸಿಜನ್ ಇರುತ್ತೆ ಅದರಲ್ಲಿ. ಬಿಕಾಸ್ ಆಫ್ ದಟ್ it is able to breathe. ಸೊ ಅದರಲ್ಲಿ ಒಂಚೂರು ಅಮೌಂಟ್ ಆಫ್ ಗ್ಯಾಸ್ ಇಸ್ ಡಿಸಾಲ್ವ್ಡ್ ಇನ್ ಅ ಲಾರ್ಜ್ ಅಮೌಂಟ್ ಆಫ್ ವಾಟರ್. ಅದಕ್ಕೆ ಹೇಳುದು ಲಿಕ್ವಿಡ್ ಸೊಲ್ಯೂಷನ್ಸ್. ಅದೇ ಲಿಕ್ವಿಡ್ ಇನ್ ಲಿಕ್ವಿಡ್ ಸಿಂಪಲ್ ಸ್ಯಾನಿಟೈಸರ್ ಯು ಕ್ಯಾನ್ ಟೇಕ್ ಅನ್ ಎಕ್ಸಾಂಪಲ್ ಆಫ್. ದೇರ್ a little bit of alcohol is mixed in water, maybe that example you can take. Then you can take an example of solid and liquid. See here, glucose, a sprinkle of glucose added to water, salt added to water, that is a liquid solution you say. ಮತ್ತೆ ಸಾಲಿಡ್ ಸೊಲ್ಯೂಷನ್ ಬಂದಾಗ ಅಗೇನ್ ಲಾರ್ಜ್ ಕ್ವಾಂಟಿಟಿ ಯಾವ್ದು ಇರಬೇಕು? ಸಾಲಿಡ್ ಇರಬೇಕು. ಅದ್ರಂಚೂರು ಗ್ಯಾಸ್ ಮೇಲೆ ಒಂದು ಲೈಕ್ ಅ ಕೋಟಿಂಗ್ ಹಾಕಿದ್ರೆ you must have seen solution of hydrogen in palladium. Palladium acts as a catalyst in most of the reactions. So it is able to fasten the reaction. So it acts like a surface for most of the reactions. So ಏನಾಗ್ತದೆ, ಹೈಡ್ರೋಜನ್ ಗ್ಯಾಸ್ ಬಂದು ಅದರ ಟಾಪ್ ಸರ್ಫೇಸ್ ಮೇಲೆ ನಿಲ್ಲುತ್ತೆ. That's why you call it solid. ದ ಮೇಲೆ ಒಂದು ಗ್ಯಾಸ್ ಬಂದು ಅದರ ಮೇಲೆ ಅಟ್ಯಾಚ್ ಆಗಿದೆ. ಸೊ ಯು ಕಾಲ್ ಇಟ್ ಸಾಲಿಡ್ ಸೊಲ್ಯೂಷನ್. ಅದರಲ್ಲಿ ಲಾರ್ಜ್ ಅಮೌಂಟ್ ಯಾರು ಕಾಣ್ತಾ ಉಂಟು ನಿಮಗೆ? ಸಾಲಿಡ್ ಕಾಣ್ತಾ ಉಂಟು. ದಟ್ಸ್ ವೈ ಯು ಕಾಲ್ ಇಟ್ ಸಾಲಿಡ್ ಸೊಲ್ಯೂಷನ್ಸ್. ಮೇನ್ ನೋಡುದು ಸಾಲ್ವೆಂಟ್. ಅಗೇನ್ ಲಿಕ್ವಿಡ್ ಅಂಡ್ ಸಾಲಿಡ್. ಲಿಕ್ವಿಡ್ ಅಂಡ್ ಸಾಲಿಡ್ amalgam of mercury, you must have heard about this amalgam of mercury. Zinc amalgam, you must have heard zinc with mercury combination. Adralli you have liquid that is mercury is in liquid state, which is on to a solid. Adke heludu solid solution. Again solid and solid. Copper dissolved in gold. Copper dissolved, gold up to 24 carats of gold. Whichever jewelry you wear that is made up of 24 carats of gold means what? 22 parts matra nimma gold, but baki 2 parts enu adu? Baki 2 parts will be your copper. Correct? So that makes it 24 carats of gold. Alli solid ಮತ್ತೆ solid. ಜಾಸ್ತಿ ಅಮೌಂಟ್ ಇರೋದು gold, ಸ್ವಲ್ಪ ಅಮೌಂಟ್ ಇರೋದು copper. That's why you call it solid solution. These questions can be asked, like, they may give you example. Identify dash type of solution it is. Copper dissolved in gold. It is what type of solution? We need to tick it, solid solution. Gaseous solution, yava type. Examples on the nodkobeku and what type of solution is it. So that is based on types of solutions. We shall move on to the next, part. That will be 1 second. Yes. So after this types of solutions, you need to understand one more term. So we saw what is solute, we saw what is solvent, we saw what is solution. We checked also the types of solutions. Next we have the solubility term. Very, very important. Very, very important to be understood. What is solubility? What do you mean by solubility? Yes, amount of solute you can dissolve in so much amount of solvent. Entha capacity. How much amount of solute can you dissolve in particular amount of solvent? Other based on solubility. Other capacity of dissolving so much amount of solute. So solubility prakara, you also have a term that is called concentration. Concentration. What do you mean by concentration? It is the amount of solute. Same thing. The amount of solute that is dissolved in a particular amount of solvent. Eshtu nanu solute dissolve madidane in so much amount of solvent. That is called concentration of the solution. Okay. Otherly, you need to understand few basic terms. That is 7 concentration terms are there. If you know this, it would be very easy for you to solve numericals, because that from the solutions chapter, you will have a topic called numerical part also. In the board exam also, you have separate numerical part section. So from there, you will be asked a few concentration term questions also, for which you need to understand the basics. So the first basic concentration term is called mass percentage. First, mass percentage andre, you see, for example, amount of solute in grams present in 100 gram of solution. So usually the representation will be W by W percentage. Andre, you weigh 10 gram of glucose, 10 gram of glucose in 90 gram of water. So, nani idannu 90 gram of water ge hakidaga, it totally makes up to how much gram? 100 gram. That is also called 100% of a solution, you see. So, my main aim is to check whether your solute which is added is in water. So, the solvent is also in water. Both are in gram and gram. That's why you call mass by mass, mass by mass. The unit is also already there here. As we use a very small amount of quantity, that's why you use it in grams. So, 10 gram dissolved in 90 gram makes it 100 gram of water. That is called mass by mass percentage. Same way, when I say, 20% of glucose is dissolved in water, andre 20 gram of glucose annu, nanu 80 gram of water ge hakidaga, it totally makes up 100%. Adu vishaya. So you just need to check the units here. Gram idre adu mass by mass percentage. Ade same way, one more variation, mass by volume idre, mass you have kept constant, that is 10 gram in maybe 90 ml of a particular solution, totally making it 100 gram, or 100%. Okay. Volume by volume. Again, ml and ml if you find, then you call it as volume by volume percentage. Again, note right. So mass by mass percentage is W by W, andre gram with gram. Mass by volume andre gram in ml. Volume by volume will be ml in ml. That's the basic thing you need to know. Coming to the important formula, that is molarity. Molarity, first of all, you need to know the formula, that is number of moles of solute dissolved in 1 liter of solution. 1 liter of solution. So much amount of solute, maybe 5 moles of solute is dissolved in 1 liter of solution. 1 liter andre 1000 ml alli eshtu moles of solute have we added. That is called molarity. Molarity in telugu. One more variation, again, molality, that is number of moles of solute. Same way, but in 1 kg of solvent. You see the terms here. This is in liter. Basically, we are checking the volume. Here, we are going to check the mass of solvent. This is full solution. This is solvent only. 1 kg of solvent only. Check the formulas here. Very, very important. If you are writing it down, please write it down. Number of moles of solute and volume of solution in liter. And the other one is number of moles of solute with mass of solvent in 1 kg. Okay. So that is molarity and molality. One more term is mole fraction. Mole fraction. I'll just put it over here only. Mole fraction. Mole fraction. Mole fraction is denoted by the symbol that is chi. Chi is somewhere like X. I'll put it as X. So, chi A is equal to, suppose you want to find out the mole fraction of any particular component. Imagine you have a binary solution. Binary solution andre one A component undo, ಇನ್ನೊಂದು B component undo, totally making it a solution. So, nange, I'm just interested in finding out the number of moles of only A. I just want to know what is only A, how much of A is present. Then I use the term mole fraction. So I'm interested in finding out mole fraction of only A. Then what am I checking here? Number of moles of A out of the total. Total will be what? Number of moles of A plus number of moles of B. Okay, so this gives you the mole fraction. Mainly, you need to know number of moles is what we are checking. That will be the concentration term. Same way, if you want to find out XB or chi B, then that will be equal to NB divided by NA plus NB. This will be the mole fraction for B. Or there is one more thing, that is, total of the mole fraction, that is XA and XB will be equal to unity. That is, will be equal to 1. This also you can use. Suppose you got XA, then what you can do is 1 minus XA will give you the value of XB. That also can be done. So, you need to know these terms, that is mass percentage, mass by volume, then volume by volume. Then you have molarity, and the other one was mole fraction. Okay. Mole fraction. We shall move on to the next term, or I think we can solve few problems before that based on these formulas. Just a second. So see here, this question is asked based on mole fraction. So calculate the mole fraction of ethylene glycol. For that, molecular formula is given in a solution containing 20% of. So you have to understand that here the percentage is given. 20% of C2H6O2, that is ethylene glycol, by mass in the kottidare. So it's basically mass percentage given. By mass in the kottidare, so you have to take it as mass percentage. So how do you check this mass percentage? First of all, how much amount of ethylene glycol is dissolved in water is what we'll have to check. So 20% under 20 gram of ethylene glycol, that is C2H6O2, is dissolved in mass by mass. I'll have to use gram by gram only. So 20 gram of C2H6O2 is dissolved in how much gram of water to make it 100? So total will be 80 gram of water. Idondu mainly you have to crack. So percentage, you need to convert it to the gram here because they have told you that it is by mass, they have told you. Okay, so 20 gram of ethylene glycol and 80 gram of water is ready. So you got to know their masses. But question asked, you see here, it is mole fraction of ethylene glycol. Mole fraction formula, formula is given as XA is equal to NA, NA divided by NA plus NB. That is number of moles of A divided by number of moles of A plus number of moles of B. That is total number of components. Suppose you talk about Na. Yar the mole fraction kelidare illi ethylene glycol. I don't want water because in a beaker you have ethylene glycol. Matte water annu mix madideve. Adralli ನಮ್ಮ interest ಏನು ಗಾಲಿ ethylene glycol the mole fraction ನೋಡಬೇಕು. Okay. So number of moles of A, that is ethylene glycol. We don't have number of moles here. Number of moles anta ellu kottilla, but we have only masses here. So you need to understand the relation between mass and number of moles. Okay, this is a very important formula. Again, basics. This is number of moles will be equal to mass by molar mass. Children, mass by molar mass. So I just have to put it separately. Number of moles of A, that is mass by molar mass of ethylene glycol divided by number of moles of. You can do it. You can try it, and then you can match up the answer with me. So number of moles of A is not given. Hence, we use mass by molar mass. So mass of ethylene glycol is what I'm interested in. Mass of ethylene glycol is 20 gram divided by molar mass of ethylene glycol. Hege nodudu? Mass is 20 gram, you got to know. Molar mass of ethylene glycol. You have to do the molecular mass thing here. Molecular mass, you have to just add up. I'm sorry, it is C2H6O2. C2, first of all, you need to know the molar mass of carbon, that is 12 into 2 plus 1 into 6. Why? Because mass of hydrogen is 1 plus oxygen is 16 into 2. You total it up, you get some answer here, that is ethylene glycol mass. Put it over here. Then take this over here and substitute here. Let me just tell you the answer. For you can try doing it. Don't need of waiting for me to do it. So you will be getting it as 62 here, molar mass. After adding 12 into 2 plus 1 into 6 plus 16 into 2, you will be getting it as 62. 62. So that will be mass by molar mass of ethylene glycol divided by, again, Na, that is mass by molar mass of ethylene glycol plus Nb. Nb will be who, children? Water, right? Water is how much gram you see? 80 gram is given. So mass by molar mass of water. Molar mass of water. How to find out? H2O is there. H2 andre 1 into 2 plus oxygen 16. That is 18 gram of water. So molar mass will be 18 gram of water. So you divide it using calculator. So 20 by 62 divided by 20 by 62 plus 80 by 18. I think you get it as around 0. 0. Last answer would be 0.068 if I'm not wrong. You can check it with your calculators, please, and let me know if the answer is right. So 0.068 will be the answer. Similarly, if of water, then what do you do? I asked you to do 1 minus, right? So 1 minus 0.068 you do. Why? Because you know that XA plus XB will be equal to 1, XA plus XB will be equal to 1. Therefore, what you do is subtract this, you get the value as around 0.932 as mole fraction of water. But anyway, it's not asked. If suppose they ask you to find out both of the mole fraction, then you do 1 minus. That will give you the answer. ಅಷ್ಟೇ ದೊಡ್ಡದೇನಿಲ್ಲ. You just have to use a formula Na divided by Na plus Nb. Na ಕೊಟ್ಟಿರಲ್ಲ, you mass will be given, so use the relation mass by molar mass. That's all. Moving on to the next problem, maybe one more problem we can try. So they've asked you to calculate molarity of a solution containing 5 gram of NaOH in 450 ml solution. All right. So again, your target is to find out molarity. Molarity formula, again, molarity is denoted by capital letter M, So number of moles of, first you write the formula along with me, number of moles of solute, number of moles of solute, second, number of moles of solute divided by volume of solution in liter, volume of solution in liter. Okay, so this is a formula. Anyway, so check here, molarity of a solution is asked. So number of moles is not there. Again, mass is there. So you know the relation mass by molar mass is a relation. Mass 5 gram ಕೊಟ್ಟಿದ್ದಾರೆ ಇಲ್ಲಿ. Molar mass of NaOH ಹುಡುಕಬೇಕು. Na is 23 plus oxygen is 16 plus 1, you get it as 40 molar mass. So 5 by 40 divided by, ಇದು ಖಾಲಿ numerator substitute ಮಾಡಿದ್ದು. Next you have volume of solution in liter. 450 ml they have given, converted to liter. So 450 divided by 1000, that will be equal to around, you get it as 0.278. Unit will be what, children? Here you have mole, illi the liter, so take it up. So it becomes mole per liter. This will be the unit. Mole per liter will be the unit. Easy. But you should know all these. You should know. Otherwise, it's waste of studying the whole chapter. It's like that. Okay. Anyway, moving on to one more problem. Yeah. So we have molality formula. Again, molality of 2.5 gram of ethanoic acid. Okay. So molality of 2.5 gram of ethanoic acid, that is 6CH3COH, that is acetic acid, which is used in vinegar, in 75 gram of benzene. Okay. So molality of 2.5 gram of ethanoic acid. Again, molality formula you apply. You don't have to wait for me. Molality is equal to, what is the formula? Number of moles of solute, same, numerator same, molality mata molarity ke numerator same, divided by mass of solvent in kg. There it was volume of solution in liter. Here it is mass of solvent in kg. Okay. So number of moles again, kotidara illa, but they have given you mass, right? Mass of ethanoic acid they have given. So mass by molar mass formula you apply for number of moles. Mass is 2.5 gram divided by acetic acid. Again, you need to check the molar mass. Carbon will be 12 into 2 because 2 carbons are there here, 1 and 2. Plus hydrogen, how many are there? 1 into 4. Plus oxygen will be 16 into 2 are there. So totally it comes up to, ethanoic acid comes up to, that is 60 gram per mole. 60 gram per mole. So molar mass is 60, you got to know, substitute, divided by mass of solvent in kg. So here they have given you in terms of gram, converted to kg, so divided by 1000. The answer would be around 0.556. Again, unit would be mole, illi moles unto, matte illi kg ide. So you take it up, so it becomes mole per kg. Mole per kg. This would be the answer. Okay, so this should be fine. This should be fine. There should be no issue with respect to these problems because all these are basics, I told you. Okay. So I just want to, summarize what did we study till here. So starting with, you study what is solution you studied, then you studied what is solute, then you studied what is solvent, then you studied what is the type of solutions you studied, then you studied what is a concentration. Concentration means amount of solute that can be dissolved in particular amount of solvent. Adano, how can you express in different forms? Are different forms only? First one you studied mass percentage, that is mass by mass percentage. Then you studied mass by volume percentage, correct? Then you studied volume by volume percentage. Formula note ko beku. Then you studied what is mole fraction you studied, mole fraction, correct? That is denoted by X. X formula you remember, XA is equal to Na divided by Na plus Nb, under number of moles. Again, you studied what is molarity. Molarity culture. Molarity is denoted by capital letter M. Maita. Then you have molality. Adrade one type of molality. Eradakku confuse agbardu. That is molality, small letter M. Molarity is number of moles of solute divided by volume of solution in liter. Molality andre number of moles of solute andre, but mass of solvent in kg. That is one thing. One more is left out. That is something called ppm. Let me tell you here only what is its use and things like that. You can add up there only, children. The number you add up there only. 1 second. Let me just, yeah. So the seventh term that you have is something called ppm. ppm. Okay. Nothing much required, but still you need to know what is this ppm. ppm full form is nothing but parts per million. Parts per million. By looking at the word only, you get to know parts per million. Andre, your solvent is related to a million, large quantity solvent. Adralli onchuru part. Iga nimma solvent is to large amount adre, solute will be a very small quantity. Adike helludu ppm, parts per million. Let me tell you that, if you want to find out in the air, air is such a huge quantity, solvent it is. Okay. So in that, maybe you are interested in finding out idu air agidre, idralli nimge you just want to find out how many dust particles are there. Imagine when you compare it to air, it's like a million parts, but when you compare it to dust particle, it's so less. First of all, it's a small quantity, right? And they are all trace quantities is what you say. So whenever you have a large quantity solvent and you want to find out a very small quantity of solute, then you use the word ppm. Athava, if you want to find out anything in trace quantity, trace andre very small quantity out of a huge amount of solvent, then you use the word parts per million. You notiರಬಹುದು ಈ geographical departments alla, they identify the number of contaminants or ಇಷ್ಟು amount of carbon monoxide ಇದೆ ಇವತ್ತು gas ಅಲ್ಲಿ ಅಥವಾ air ಅಲ್ಲಿ. They put it in terms of ppm. You must have observed 10 to the power 6 ppm like this. Okay, so this means that it is applied for only trace quantity identification. Maybe you talk about seawater. Seawater is so huge, and in that you want to find out how much amount of contaminants are there, ಅಥವಾ ಎಷ್ಟು dust particles ಇದೆ, ಅಥವಾ unwanted particles ಎಷ್ಟಿದೆ ಅಂತ ನೋಡ್ಲಿಕ್ಕೆ. Sea is so huge, and you want to find out dust particles which is in less quantity. ಅದಕ್ಕೆ use ಮಾಡೋದು ppm. So they may ask you this question in as an MCQ. Where do we use this parts per million to find out the concentration and trace quantity? Remember that. And parts per million goes as, again, million in the sense it is 10 to the power 6 ppm. 1 ppm will be equal to, how to find out? Understand that it is number of parts. Number of parts. Now, I was interested in only finding out the dust particles. So, number of parts of a particular component. This is a formula. Number of parts of a particular component. This will be the numerator. Divided by total number of parts. Divided by total number of components or total number of parts of all the components. Like that also you can see, or total number of components into 10 to the power 6. This will be the formula for ppm, and it is used to find out the concentration and trace quantity. So totally there are 7 of them. Okay. So that is one thing. That is one thing you need to know. So including this concentration term, totally we have learned 7 concentration terms. That is ppm also is one of them. All right. So mass by mass, mass by volume, volume by volume, mole fraction, molality, and the last one is ppm. I hope there is no doubt from this part, that is concentration terms and measuring concentration. So we shall move on to the next topic, that will be solubility is done, concentration is done. Next we move on to binary solution. Focus on this term. That is a binary solution. First of all, you understand by the word what is binary solution. Binary solution will be a mixture of two components. Solution and it can be any number, because rarely different types of gases are there. I told you it's a homogeneous mixture. Any number of components can be there, but out of it, if only two components are present, then you call it a binary solution. Okay. So imagine you have A plus B, that only sugar plus water, you can take it as a binary solution. So based on this, you need to learn some of the important measurement of solubility, that is factors affecting solubility of a, focus on only this part, solid in a liquid. Please focus on this part, solid in a liquid. Whenever I talk about this, you don't have to understand it in a complex term. You just know that solid in a liquid andre uppannu neeralli kallisidene. So what will happen? Effect of pressure, effect of temperature, ಇದನ್ನೆಲ್ಲ ಅರ್ಥ ಮಾಡಬೇಕು. ಹೀಗೇನೆ ಅರ್ಥ ಮಾಡಬೇಕು. Simple example ಹಾಕಿ ಅರ್ಥ ಮಾಡಬೇಕು ಆಯ್ತಾ. So factors affecting solubility of a solid in liquid. So you know that in your beaker there is a little bit of water and a little bit of solid ಉಪ್ಪು ಕಲಡಿಸಿ you have a solution. This is a binary solution, solid and a liquid. So based on that, you need to understand, yavaga solubility ಜಾಸ್ತಿ ಆಗ್ತಿದೆ. Okay, ಉಪ್ಪು ಈಗ soluble ಆಗಿದೆ, but what are the factors affecting it? Temperature ಜಾಸ್ತಿ ಮಾಡಿದ್ರೆ ಏನಾಗ್ತದೆ, pressure ಜಾಸ್ತಿ ಮಾಡಿದ್ರೆ ಏನಾಗ್ತದೆ, that and all you need to understand. Okay, so first of all, you talk about the first factor, that is nature of solute and solvent. Okay, polar solute dissolve in polar solvents, non-polar solute dissolve in non-polar solvents. Simple concept, that is like dissolves like. Always polar andre you talk about NaCl. It has two poles, children. Poles andre it is type of an ionic compound. Ionic compound is formed by ions, Na plus and Cl minus. So this has two poles, you see, plus and minus. There are two charges, charge separation is there. So you call it a polar solvent whenever there is charge separation. Even in water, H2O splits into H plus and OH minus. Again, it is said to be polar. Why? Because it has two poles there. So whenever you dissolve uppu, that is NaCl, in water, it is able to dissolve. Why? Because both are polar, plus with minus. Same way, when you talk about non-polar solvents, they don't split into ions. For example, glucose, C6H12O6, it is added to maybe benzene.
Clarity.
Children will just get back. Give me a minute. There is an internet issue. I will just present the screen. Just hold on. Just go through the points that is already given. 1 minute. Sorry for the interruption. I hope you have gone through the points that I gave you. Hope you can see the screen also. Yes. Yeah. So we were talking about solubility of a solid in liquid. Yeah. Here we were. So factors affecting solubility of a solid in liquid. So you need to, I was talking about polar solvents. Right. Yes. Polar solvents. So Na plus Cl minus is there. H2O splits into H plus and OH minus. Together, when we put it in a beaker and dissolve, of course it dissolves. No? Plus with minus, plus with minus. Yes, it can dissolve. So always like dissolves like polar solvents. Ionic compounds will dissolve in ionic solvents. Organic compounds like, non-polar. Non-polar, you take an example. I was talking about glucose, maybe C6H12O6 is an organic compound, does not split into ions. This, if it is dissolved in benzene, maybe it's an organic compound, does not split into ions. So, covalent nature, we can dissolve it covalent nature only. But NaCl, if I add it to, benzene, it's not going to dissolve. Or NaCl, if I add it to kerosene, it's not going to dissolve. NaCl, if I add it to any organic compound, it's not going to dissolve because like is only going to dissolve like. That is one nature of solvent point you need to understand. Okay. That's like a fundamental thing you need to know. Anyway, so that is one factor. Again, effect of temperature. This is one of the important factor of solubility of solid and liquid. Again, getting back to. So effect of temperature of solubility of solid and liquid. So I was having water here. ಇಲ್ಲಿ ನೀರಿತ್ತು ಇದಕ್ಕೆ ನಾವು salt add ಮಾಡಿದ್ವಿ. Imagine. ಆಯ್ತಾ? Here we put on salt. ಈಗ effect of temperature on the solubility. ಇದಕ್ಕೆ ನಾನು temperature increase ಮಾಡುದು. Maybe I'm going to heat it. You know that, of course, when we heat, uppu, it will, of course, dissolve faster in liquid. Begane coloredista barteve now, So basically, as the temperature increases, solubility of whom? Solid, in whom? Liquid increases, of course. But, let's not, consider that as an example. Maybe you consider this effect of temperature as an endothermic reaction and an exothermic reaction. Let me just go back to the slide. So they have asked you to, if the dissolution process is endothermic, first of all, focus on the word, what is dissolution? Dissolution andre dissolve agudu. When you added salt to water, Of course, it is dissolving, right? That process is called dissolution. But ಇನ್ನೊಂದು process ಇದೆ, like, ಇದು dissolve ಆಗ್ತಾ ಹೋದಾಗ you call it dissolution. ತೊಂದ್ರೆ ಇಲ್ಲ, ಆರಾಮ್ಸೆ ಎಲ್ಲ dissolve ಆಗ್ತಾ ಉಂಟು. Dissolution, okay? But you meet one point of time, ಅಥವಾ ಒಂದು point of time ಬರ್ತದೆ wherein no more salt can dissolve. ನೀವು 10 ಸ್ಪೂನ್ ಹಾಕಿ 100 ಸ್ಪೂನ್ ಹಾಕಿ, but then it's not going to dissolve only. ಗೊತ್ತಾಯ್ತಾ? ಸಾಲ್ಟ್ ಹಾಗೇನೆ ನಿಲ್ತದೆ, ಬಿಕಾಸ್ those salt particles are going to collide with these particles and separate out here only. ಆದ್ರೆ ಅವರು ಸಾಲಿಡ್ ತರಾನೇ ನಿಲ್ತಾರೆ ಅಲ್ಲಿ, ಹೀಗೆ they will remain as salt only, they won't dissolve, you will see them. So what do you call that such type of solution? You call it a saturated solution ಅಂತ ಹೇಳ್ತೇವೆ. Saturated solution. Okay, saturated solution ಫಾರ್ಮ್ ಆಗಿದೆ ಅಂದ್ರೆ ಅಲ್ಲಿ ಯಾವ ಪ್ರೊಸೆಸ್ ಆಗ್ತಿತ್ತು? ದೇರ್ ವಾಸ್ ಕ್ರಿಸ್ಟಲೈಸೇಷನ್. ಕ್ರಿಸ್ಟಲೈಸೇಷನ್ ಅಂದ್ರೆ ಇನ್ನು ಸಾಲ್ಟ್ ಡಿಸಾಲ್ವ್ ಆಗಲ್ಲ, ಇಟ್ ಇಸ್ ಗೋಯಿಂಗ್ ಟು ಸ್ಟ್ಯಾಂಡ್ ಲೈಕ್ ಅ ಕ್ರಿಸ್ಟಲ್ ಓನ್ಲಿ. ಕ್ರಿಸ್ಟಲೈಸೇಷನ್ ಆಪೋಸಿಟ್ ಏನು? ಡಿಸ್ಸೊಲ್ಯೂಷನ್ ಅಂತ ಹೇಳ್ತೇವೆ. ಡಿಸ್ಸೊಲ್ಯೂಷನ್ ಅಂದ್ರೆ ಡಿಸಾಲ್ವ್ ಆಗತ್ತೆ, ಕ್ರಿಸ್ಟಲೈಸೇಷನ್ ಅಂದ್ರೆ ಡಿಸಾಲ್ವ್ ಆಗಲ್ಲ ಎನಿಮೋರ್. ವಾಟ್ ಟೈಪ್ ಆಫ್ ಸೊಲ್ಯೂಷನ್ ಇಸ್ ಅ ಸ್ಯಾಚುರೇಟೆಡ್ ಸೊಲ್ಯೂಷನ್ ಅಂತ ಹೇಳ್ತೇವೆ. ಓಕೆ, ಬಟ್ ಈಗ ಕ್ರಿಸ್ಟಲೈಸೇಷನ್ ಆ ಟಾಪಿಕ್ ನಮ್ಗೆ ಬೇಡ. ವಿ ಆರ್ ಟಾಕಿಂಗ್ ಅಬೌಟ್ dissolution because we need that salt to be dissolved in that particular solvent. So if the dissolution process is endothermic, what do you mean by endothermic, children? Endothermic, again basics. Endothermic andre where heat energy is, so salt ittu, okay, it is dissolving in water and is becoming a ಸೊಲ್ಯೂಷನ್. ಇದಕ್ಕೆ ಹೇಳುದು ನಾವು ಡಿಸೊಲ್ಯೂಷನ್. ಫಾರ್ವರ್ಡ್ ರಿಯಾಕ್ಷನ್ ಗೆ ಹೇಳುದು ಡಿಸೊಲ್ಯೂಷನ್. ಸಾಲ್ಟ್ ಇತ್ತು, ಅದು ಲಿಕ್ವಿಡ್ ಆಗಿ ಕನ್ವರ್ಟ್ ಆಗೋದು ನಮ್ಗೆ ಡಿಸೊಲ್ಯೂಷನ್ ಪ್ರೊಸೆಸ್ ಅಂತ ಹೇಳಿದ್ದೆ. ಸೊ ಇಫ್ ದಿಸ್ ಇಸ್ ಅನ್ ಎಂಡೋಥರ್ಮಿಕ್ ಪ್ರೊಸೆಸ್, ಎಂಡೋಥರ್ಮಿಕ್ ಅಂದ್ರೆ ಏನು? ಡೆಲ್ಟಾ ಎಚ್ ವಿಲ್ ಬಿ ಅ ಪಾಸಿಟಿವ್ ವ್ಯಾಲ್ಯೂ. ಡೆಲ್ಟಾ ಎಚ್ ಇಸ್ ಅ ಪಾಸಿಟಿವ್ ವ್ಯಾಲ್ಯೂ. ಅಂದ್ರೆ ಎಂಡೋಥರ್ಮಿಕ್ ರಿಯಾಕ್ಷನ್ ಅಂದ್ರೆ ಈ ಸಾಲ್ಟ್ ಇಸ್ ಗೋಯಿಂಗ್ ಟು ಅಬ್ಸಾರ್ಬ್ ಎನರ್ಜಿ. ಇಟ್ ಇಸ್ ಗೋಯಿಂಗ್ ಟು ಅಬ್ಸಾರ್ಬ್ ಎನರ್ಜಿ, ಓಕೆ, ಅಂಡ್ dissolve in water or absorb heat and it is going to dissolve in water. So ನೀವು ಎಷ್ಟೇ ಟೆಂಪರೇಚರ್ ಜಾಸ್ತಿ ಮಾಡ್ತೀರಾ, ಅದನ್ನೆಲ್ಲ ಏನ್ ಮಾಡ್ತದೆ ಆ ಸಾಲ್ಟ್? ಇಟ್ ವಿಲ್ ಟೇಕ್ ಅಪ್ and it get dissolved in the solution. ಅದಕ್ಕೆ ಹೇಳುದು it is delta H positive ಅಂತ, ಕರೆಕ್ಟಾ? So salt is going to absorb energy and slowly is going to dissolve in the water. ಅದಕ್ಕೆ ಹೇಳುದು dissolution process, where it right hand side ಅಂದ್ರೆ forward direction ಇಂದ right hand side ಗೆ ಹೋಗುವಾಗ it is going to dissolve ಅಂತ ಹೇಳಿದ್ರು. So delta H is positive ಅಂದ್ರೆ ಏನು? It is going to absorb. ನೀವು ಎಷ್ಟೇ ಟೆಂಪರೇಚರ್ ಜಾಸ್ತಿ ಮಾಡಿ it's going to absorb and become soluble. No problem at all. So how do you say? For an endothermic reaction, always when there is increase in temperature, the solubility increases. Solubility increases. This you have to refer the equilibrium chapter. ಅಲ್ಲಿ ಒಂದು ಲೀ-ಚಾಟೆಲಿಯರ್ಸ್ ಪ್ರಿನ್ಸಿಪಲ್ ಅಂತ ಇತ್ತು. ನೀವು ಎಷ್ಟೇ ಟೆಂಪರೇಚರ್ ಜಾಸ್ತಿ ಮಾಡಿದ್ರು, if delta H is positive, as you increase the temperature, the reaction will proceed in the forward direction in order to balance it. Okay, but if suppose the same case salt, it is becoming a solution, you dissolve ಮಾಡ್ತಿದ್ದಿ, right, is becoming a solution. But if that particular reaction is exothermic ಅಂದ್ರೆ wherever heat energy is released, ಅಂದ್ರೆ ಇದು ಡಿಸಾಲ್ವ್ ಆಗುವಾಗ there is going to be heat energy released. ಆಲ್ರೆಡಿ ಹೀಟ್ ಎನರ್ಜಿ ಇದೆ, ನೀವು ಪುನಃ ಹೀಟ್ ಸಪ್ಲೈ ಮಾಡ್ತೀವಿ, ಆಲ್ರೆಡಿ ಎಕ್ಸ್ಟ್ರಾ ಇದೆ ಅಲ್ಲಿ, ಆಲ್ರೆಡಿ ಜಾಸ್ತಿಯೇ ಇದೆ ಹೀಟ್ ಎನರ್ಜಿ. ಅಗೈನ್ ಯು ಗೋಯಿಂಗ್ ಟು ಸಪ್ಲೈ ಹೀಟ್. ಆಗ ಏನಾಗ್ತದೆ, ಇನ್ ಆರ್ಡರ್ ಟು ಬ್ಯಾಲೆನ್ಸ್ ಇಟ್ ಸೆಲ್ಫ್, ದ ರಿಯಾಕ್ಷನ್, ಈ ಹೀಟ್ ಅನ್ನು ಆಫ್ ಕೋರ್ಸ್ ಇಟ್ ವಿಲ್ ಬಿ ಯೂಸಿಂಗ್ ಅಂಡ್ ಗೋಯಿಂಗ್ ಇನ್ ವಿಚ್ ಡೈರೆಕ್ಷನ್? ಬ್ಯಾಕ್ವರ್ಡ್ ಡೈರೆಕ್ಷನ್. ಬ್ಯಾಕ್ವರ್ಡ್ ಡೈರೆಕ್ಷನ್ ಅಂದ್ರೆ ಎಂತಾಗ್ತದೆ ಅಲ್ಲಿ? ಸೊಲ್ಯೂಷನ್ ಇಸ್ ಬಿಕಮಿಂಗ್ ಅ ಸಾಲ್ಟ್. ನಮ್ಗೆ ಸಾಲ್ಟ್ ಬೇಡ ಅಲ್ಲ, ಇಟ್ ಶುಡ್ ಬಿಕಮ್ ಅ ಸೊಲ್ಯೂಷನ್ ಅಲ್ಲ. ಹಾಗಾದ್ರೆ solubility decreases. According to Lee-Chatelier's principle, for an exothermic reaction, as you increase the temperature, already heat ಇದೆ, again you're going to supply. ಆಗ in order to balance itself ಎಂತಾಗ್ತದೆ, the reaction will proceed in forward direction, hence the solubility decreases. Very, very important to be understood. So this question they may ask you for 2 marks, may be in board exams or competitive. So you should know that whenever it is an endothermic reaction, effect of temperature on solubility of solid and liquid, solubility increases for an endothermic reaction. For exothermic reaction, solubility decreases is what you know. No need of explaining Lee-Chatelier's principle, but you should have an idea about what is Lee-Chatelier's principle. ನೀವು ಜಾಸ್ತಿ ಹೀಟ್ ಮಾಡಿದ್ರು, in order to balance it, ಯಾವ ಸೈಡ್ ಅಲ್ಲಿ ಹೋಗ್ತದೆ ಅಂತ ನೀವು ನೋಡ್ಕೋತೀವಿ. Okay, so that is regarding solubility of a solid and liquid, ಅದರಲ್ಲಿ effect of temperature. What about pressure, children? ಇದಕ್ಕೆ ನಾವು ಸಾಲ್ಟ್ ಹಾಕಿದ್ವಿ, ಇಲ್ಲಿ ಸಾಲ್ಟ್ ಯೂಸ್ ಮಾಡಿದ್ವಿ, ಕರೆಕ್ಟಾ? ಇಲ್ಲಿ ನಾವು ಸಾಲ್ಟ್ ಯೂಸ್ ಮಾಡಿದ್ವಿ. ಇದಕ್ಕೆ ನಾವು ಪ್ರೆಷರ್ ಹಾಕಿದ್ರೆ, ಸಾಲ್ಟ್ ಗೆ ಪ್ರೆಷರ್ ಹಾಕಿದ್ರೆ, ಇಸ್ ದೇರ್ ಎನಿ ಇಫೆಕ್ಟ್? ನಾನೊಂದು ಸಾಲಿಡ್ ಮೇ ಬಿ ಈ ಪೆನ್ನಿಗೆ ನಾನು ಎಕ್ಸ್ಟ್ರಾ ಪ್ರೆಷರ್ ಹಾಕ್ತೇನೆ. ವಿಲ್ ದೇರ್ ಬಿ ಎನಿ ಇಫೆಕ್ಟ್ ಆನ್ ದಿಸ್? ನೋ. ವಿಲ್ ಇಟ್ ಸಾಲಿಬಿಲಿಟಿ ಇನ್ಕ್ರೀಸ್ ಸಮಥಿಂಗ್? ಇಲ್ಲ. ಯಾಕಂದ್ರೆ ಯಾವಾಗಲೂ ಪ್ರೆಷರ್ ಹ್ಯಾಸ್ ನೋ ಇಫೆಕ್ಟ್ ಆನ್ ದ ಸಾಲಿಬಿಲಿಟಿ ಆಫ್ ಸಾಲಿಡ್ ಇನ್ ಅ ಲಿಕ್ವಿಡ್. Because it's already solid, it's incompressible in nature, So adike effect of pressure won't be there. So see here, just read it out here. Effect of pressure, this point. Pressure does not have any significant effect. Does not have any significant effect on solubility of solids in liquids, as these are highly incompressible. Kali temperature matra, there are two conditions you should know: exothermic and endothermic. Endothermic ge solubility increase agtade, exothermic ge solubility decrease agtade. That's one thing you need to identify. Anyway, moving on. So solubility of solid and liquid, only those 2 points you need to remember. Okay. Next, you have factors affecting the solubility of gas in liquid. Very important. Solubility of a gas in liquid. So best example is to take Coca-Cola. I know it's your favorite soft drink, but you take an example of that. ಅದು ನಾವು ಹೇಳ್ತೀವಿ ಕೋಕಾ-ಕೋಲಾ ಕುಡಿಬೇಡಿ ಅಪ್ಪ, ಯಾಕೆ? ಅದು ಖಾಲಿ ಒಂದು ಶುಗರ್ ಸೊಲ್ಯೂಷನ್, ಜಸ್ಟ್ ಅ ಮೀಟಾ ಸೊಲ್ಯೂಷನ್. ಅದು ಅದ್ರ ಮೇಲ್ಗಡೆ ಕಾರ್ಬನ್ ಡೈಆಕ್ಸೈಡ್ ಅನ್ನು ಡಿಸಾಲ್ವ್ ಮಾಡಿ ಚೆನ್ನಾಗಿ ಒಂದು ಸಾಫ್ಟ್ ಡ್ರಿಂಕ್ ತರ ಕೊಡ್ತಾರೆ. ಕರೆಕ್ಟಾ? ನೀವು ಅದ್ರ ಬಾಟಲ್ ಓಪನ್ ಮಾಡುವಾಗ ಸಡನ್ಲಿ ಒಂದು ಫಿಝಿ ಸೌಂಡ್ ಬರ್ತದೆ. ಅಂದ್ರೆ ದಟ್ಸ್ ಕಾರ್ಬನ್ ಡೈಆಕ್ಸೈಡ್ ಇವಲ್ಯೂಷನ್. ಇಟ್ಸ್ ಸ್ಟೋರ್ಡ್ ಅಂಡರ್ ಹೈ ಪ್ರೆಷರ್. ಕರೆಕ್ಟ್? ಅಲ್ಲಿ ಆಲ್ರೆಡಿ ನಾನು ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡಿ ಆಯ್ತು ಎಂತ ಅದು ಕಾನ್ಸೆಪ್ಟ್ ಅಂತ. ಸೊ ಯು ಟಾಕ್ ಅಬೌಟ್ ಅ ಕೋಕಾ-ಕೋಲಾ ಬಾಟಲ್. ಐ ಟೋಲ್ಡ್ ಯು ದ ಗ್ಯಾಸ್, ಆ ಫಿಝಿ ನೇಚರ್ ಉಂಟಲ್ಲ, ದಟ್ಸ್ ವಾಟ್ ಗಿವ್ಸ್ ಇಟ್ಸ್ ಟೇಸ್ಟ್. In order for that gas to go and sit inside the bottle, of course, what should you apply on the top? Pressure ಹಾಕ್ಬೇಕಲ್ಲ. ಪ್ರೆಷರ್ ಹಾಕಿದ್ರೆ ಮಾಸ್ ಅದು ಗ್ಯಾಸ್ ಹೋಗಿ ಅದ್ರ ಒಳಗೆ ಕುತ್ಕೊಳ್ಳೋದು. ಇಲ್ಲ ಅಂದ್ರೆ it can't sit there, because gases are moving randomly. Their intermolecular forces are very weak. ಅವರು ಎಸ್ಕೇಪ್ ಆಗ್ತಾರೆ ಈಸಿಲಿ. ಬಟ್ ಪ್ರೆಷರ್ ಹಾಕಿದ್ರೆ ಮಾತ್ರ ಗ್ಯಾಸ್ ಹೋಗಿ ಡಿಸಾಲ್ವ್ ಆಗೋದು. ರೈಟ್? ಸೊ ದಟ್ ಇಸ್ ವಾಟ್ ಯು ಹ್ಯಾವ್, effect of pressure over here. Before I get into detail of effect of pressure, can you just talk about effect of temperature, children? What will happen if I increase the temperature here? ಅದೇ ಕೋಕಾ-ಕೋಲಾ ಬಾಟಲಿಗೆ ಅದೇ ನಾನು ಹೀಟ್ ಮಾಡಿದ್ರೆ ಆ ಗ್ಯಾಸ್ ನಿಲ್ಲತ್ತಾ? ಇಲ್ಲ. They will just evaporate from there, or they will just escape from there. So solubility of a gas in liquid will decrease with the increase in temperature. Solubility of a gas will increase when I increase pressure. Pressure hakidre matra gas hogi olagade nillatte. That is right. Okay. So first of all, let's talk about effect of pressure. That is given beautifully by a person named Henry's law. Henry's law, very important. 2 marks question for your board exams, as well as in competitive also. They ask based on this few questions and all, like significance and all. I'll tell you. So Henry's law states that the partial pressure of the gas in vapor phase is proportional to the mole fraction of the gas in solution. Simply, I'll tell you in another form, just to understand. You can also say that solubility of a gas in a solution, okay, is proportional to the partial pressure of the gas above the solution. Partial pressure of the gas above the solution. Andre solubility of gas in a solution andre ಎಷ್ಟು ಕಾರ್ಬನ್ ಡೈಆಕ್ಸೈಡ್ ಹೋಗಿ ಅದ್ರ ಒಳಗೆ ಡಿಸಾಲ್ವ್ ಆಗಬೇಕು. ಸಾಲ್ಯುಬಿಲಿಟಿ ಆಫ್ ಗ್ಯಾಸ್ ಇನ್ ಅ ಸೊಲ್ಯೂಷನ್ ಇಸ್ ಡೈರೆಕ್ಟ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್ ಟು ಎಂತ ನಾವು ಅಪ್ಲೈ ಮಾಡ್ಬೇಕಲ್ಲಿ? ಪಾರ್ಷಿಯಲ್ ಪ್ರೆಷರ್ ಅಪ್ಲೈ ಮಾಡ್ಬೇಕು. ವೈ ಪಾರ್ಷಿಯಲ್ ಇಸ್ ಯೂಸ್ಡ್? ಬಿಕಾಸ್ ಯು ಆರ್ ಓನ್ಲಿ ಟಾಕಿಂಗ್ ಅಬೌಟ್ ಒನ್ ಗ್ಯಾಸ್. ಇಮ್ಯಾಜಿನ್ ದರ್ ವರ್ ಮೆನಿ ಗ್ಯಾಸಸ್, ಇಟ್ಸ್ ಓನ್ ಪಾರ್ಷಿಯಲ್ ಪ್ರೆಷರ್. ವಾಟ್ ಎವರ್ ಪ್ರೆಷರ್ ದೇ ಇಂಟ್ರೊಡ್ಯೂಸ್ ಇಸ್ ಕಾಲ್ಡ್ ಪಾರ್ಷಿಯಲ್. ಇಂಡಿವಿಜುವಲ್ ಪ್ರೆಷರ್ ಇಸ್ ಕಾಲ್ಡ್ ಪಾರ್ಷಿಯಲ್ ಪ್ರೆಷರ್. Total pressure ಅಂತ ಹೇಳಿದ್ರೆ it's like all of the gases together what they put. Now we are talking about only one gas. That's why partial pressure term is used. So solubility of a gas in a liquid is directly proportional to the partial pressure applied on the gas or of the gas above the solution. Okay. Or you can also say that partial pressure of the gas in vapor phase. Vapor phase ಅಂದ್ರೆ ಇಲ್ಲಿ ನಿಮ್ಮ ಕಾರ್ಬನ್ ಡೈಆಕ್ಸೈಡ್ ಇತ್ತಲ್ಲ, ಕೋಕಾ-ಕೋಲಾ ಬಾಟಲ್ ಇತ್ತಲ್ಲ, ಇಲ್ಲಿ ಕಾರ್ಬನ್ ಡೈಆಕ್ಸೈಡ್ ಇತ್ತಲ್ಲ, ಇದು ವೇಪರಿಗೆ ಎಸ್ಕೇಪ್ ಆಗ್ತದಲ್ಲ. ಕರೆಕ್ಟಾ? Because they are highly, they have less intermolecular forces of attraction. That's why they escape very easily, So ಇದಾಗಬೇಕಿದ್ರೆ it is directly proportional to mole fraction of the gas in the solution. Mole fraction ಅಂದ್ರೆ ಎಷ್ಟು ಅಮೌಂಟ್ ಇದೆ, ಇದು ಎಷ್ಟು ಅಮೌಂಟ್ ಇದೆ ಅಷ್ಟೇ ವೇಪರ್ಸ್ ಬರೋದಲ್ಲ. ಅಂಡರ್ಸ್ಟೂಡ್? ಕಾರ್ಬನ್ ಡೈಆಕ್ಸೈಡ್ ಎಷ್ಟು ಡಿಸಾಲ್ವ್ ಆಗಿದೆ Only so many vapors can be evolved. That is what it says. So Henry's law says that partial pressure of the gas in vapor phase, illi eshtu vapors irutta, that is proportional to the mole fraction, how much ever you have taken in the solution. Simple. So the expression is given as P is equal to KH into X. P is equal to KH into X is the expression, wherein P stands for partial pressure, X stands for mole fraction. Whatever terms you used here, see here, partial pressure, ಮತ್ತೆ ಇನ್ನೊಂದಂತ X is nothing but mole fraction. ಈ ಎರಡು term ಇದೆ ಇಲ್ಲಿ. And there is one more. Actually, partial pressure is directly proportional to mole fraction of the solution. ಈ partial pressure equal ಮಾಡಬೇಕಿದ್ರೆ, you need to apply a constant, that is KH into X. And that KH is called Henry's constant. KH is a Henry's law constant. ಇಲ್ಲಿದೆ. And Henry's law constant is different for different gases at a particular temperature. Higher the value of KH, anyway, I'll talk about it. So I hope you noted down the expression with the formula. The statement, the partial pressure of the gas in vapor phase, ಎಷ್ಟು vapor ಅಲ್ಲಿ ಇರುತ್ತಾ, is directly proportional to mole fraction of the gas in the solution. Expression is P is equal to KH into X, where P stands for partial pressure, X stands for mole fraction, and KH stands for Henry's constant. I just need a moment to explain this. One second. Okay. Oh. 1 minute. Yeah. So you just got to know that it is P is equal. Yeah, it is P is equal to P is equal to P is equal to KH into X is what you got to. Correct? ಈಗ P is equal to KH into X, where P stands for partial pressure, X stands for mole fraction. Now understand. P ಮತ್ತೆ mole fraction is directly proportional. ಇದು ಜಾಸ್ತಿ ಇದ್ರೆ solubility of the gas in a liquid also ಜಾಸ್ತಿ. All these go together. They are all friends with each other. Partial pressure, mole fraction, solubility. So pressure ಜಾಸ್ತಿ ಇದ್ರೆ solubility increase ಆಗ್ತದೆ. Pressure ಜಾಸ್ತಿ ಇದ್ರೆ mole fraction increase ಆಗ್ತದೆ. ಎಲ್ಲ directly proportional. Okay. Only enemy is Henry's constant, that is KH. ಇದು ಒಂಥರ ಬೇರೆನೆ. It is always inversely proportional. Because KH value ಇದೆಯಲ್ಲ, KH value is studied with variation in temperature, children. KH value is studied by varying temperature for different gases. For different gases, you will have different KH value. And they have studied by varying temperature, by studying temperature as well. But namge temperature bed alla, children. I just told you that whenever you heat this Coca-Cola bottle, alli idda gas escape ಆಗ್ತದಲ್ಲ, ನಮಗೆ ಕಾರ್ಬನ್ ಡೈಆಕ್ಸೈಡ್ ಅಲ್ಲಿ ಕೂರ್ಬೇಕು. But then when you increase the temperature, ಏನಾಗ್ತದೆ, ಕಾರ್ಬನ್ ಡೈಆಕ್ಸೈಡ್ will escape. ನಮಗೆ ಟೆಂಪರೇಚರ್ ಬೇಡ. ಟೆಂಪರೇಚರ್ ಇಸ್ ಇನ್ವರ್ಸ್. ನಮಗೆ ಅದು ದುಶ್ಮನ್, ಅದು ನಮ್ಮದು. ಟೆಂಪರೇಚರ್ ಬೇಡ ನಮಗೆ ಗ್ಯಾಸ್ ಡಿಸಾಲ್ವ್ ಆಗ್ಲಿಕ್ಕೆ. So temperature is friends with whom? Henry's constant. Henry's constant will be inversely proportional to whom? Solubility. Henry's constant will be inversely proportional to whom? Mole fraction. Henry's constant will be inversely proportional to whom? Partial pressure. ಇದು ಎರಡು ಫ್ರೆಂಡ್ಸ್ ಯಾರು? KH ಮತ್ತೆ ಟೆಂಪರೇಚರ್. This is enemy with solubility. This is enemy with KH is enemy with mole fraction. KH is enemy with partial pressure. But it is only friends with whom? Temperature. This, if you keep it in your head, then your answering will be easy. I'll just show you how to answer also. Just a moment again. Second. You know, you talk about yeah. Okay. So maybe this one. ಇಲ್ಲಿ ನೋಡಿ, ಹೀಲಿಯಂ ಇದು KH ವ್ಯಾಲ್ಯೂ ಇಷ್ಟು 144.97 ಕಿಲೋ ಬಾರ್ ಅಂತ ಇದೆ. ಓಕೆ, ಹೌ ಡಿಡ್ ದೇ ಸ್ಟಡಿ? ಬೈ ವೇರಿಂಗ್ ಇಟ್ಸ್ ಟೆಂಪರೇಚರ್ ಅಟ್ ವಾಟ್ ಟೆಂಪರೇಚರ್ ನೋಡಿ, 293 ಕೆಲ್ವಿನ್ಗೆ ಇಷ್ಟು ಅದರ KH ವ್ಯಾಲ್ಯೂ. ಓಕೆ, ಸೊ ಇದ್ರ ವ್ಯಾಲ್ಯೂ ಇಷ್ಟಿದ್ರೆ ಹೈಡ್ರೋಜನ್ ನೋಡಿ 293 ಕೆಲ್ವಿನ್ಗೆ 69.16 ಇದೆ. ಸೊ ಹೂ ಇಸ್ ಮೋರ್ ಸಾಲ್ಯುಬಲ್ ಅಂತ ಆಗ ನಾನು ತೋರಿಸಿದೆ. ಸಾಲ್ಯುಬಿಲಿಟಿ ಮತ್ತೆ ಪ್ರೆಷರ್ ಮಾತ್ರ, ಪ್ರೆಷರ್ ಎಲ್ಲ ಡೈರೆಕ್ಟ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್, ಬಟ್ Henry's constant is inversely proportional to your solubility. Okay. Now my question is, out of these two, the first two, helium and hydrogen, yaar soluble jasti? The one who has higher KH value will be less soluble. Correct? less soluble. The one with lower KH value will be highly soluble. Yarigili lower KH value 69.16 adiyardu hydrogen. So hydrogen is more soluble than which one? Helium at so and so temperature. Jasti KH value idre solubility will be kammi. That's the idea. Okay. So same way if you talk about argon and carbon dioxide in lead 298 Kelvin, 298 Kelvin. They have checked the temperature. Carbon dioxide ge 1.67 ashte irudu, but argon ge 40.3. Andre who will be more soluble here? 1.67 will be more soluble. Lesser the KH value, more will be the solubility. Very, very important to be understood because competitive also they'll ask. Even in the MCQs also they will ask who will be more soluble or not. You should know. You should know that topic. You should know. Okay. So these are the points from Henry's law. So first you studied what is Henry's law statement. After Henry's law statement, you went to what is the expression for Henry's law. Let me just revise it quickly once again so that you don't forget it. Yeah. So, yeah, sure was it. So effect of pressure under that Henry's law. Here, what are we talking about? Solubility of gas and liquid. Okay, I'll be revising once again, all of them together. So effect of pressure under that Henry's law. Read the statement once again. I want you all to read it aloud. The partial pressure of the gas in vapor phase is proportional to the mole fraction of the gas in the solution. P is equal to KH into X is a formula for Henry's law, where P stands for partial pressure of the gas, KH stands for Henry's constant, X stands for mole fraction. And KH value is studied by varying temperatures and it is different value for different gases. Higher the value of KH, lower will be the solubility of the gas in liquid. So therein we went to the expression wherein Henry's law is directly proportional to temperature. Henry's law is inversely proportional to solubility, partial pressure and mole fraction, all of these. Okay. So that was about Henry's law. Now moving on to the applications of Henry's law. Let me just tell you a few applications of Henry's law here. 1 second again. So applications andre you can talk about this general idea. That is first one that you've already studied. Yeah. First one. You can talk about soft drinks. Soft drinks. In soft drinks or aerated drinks, just now I told you Coca-Cola bottle, we use carbon dioxide gas in order to make the drink fizzy in nature. Fizzy andre a carbon dioxide chill agi ಒಂದು fizz barbekitre, you need to have you make use of Henry's law. That is one of the application in daily life. Or you can talk about the atmospheric pressure. Atmospheric pressure. Okay. On sea water. On sea water. Okay. Alli sea water alli enirutte, fishes irutte. Okay. Hope this looks like a fish. Yes. So there are fishes, How will they be able to breathe? Because of oxygen gas present in the sea water, right? Who is applying pressure there? Atmospheric pressure is there, because of which oxygen will be soluble in this, sea water. Suppose it is really hot, like it's where a lot of high temperature is there. Imagine it's too high, because of which what happens? This oxygen won't be able to dissolve. Aga fishes ಗೆಲ್ಲ breathe ಮಾಡಲಿಕ್ಕೆ ತುಂಬಾ ಕಷ್ಟ ಆಗ್ತದೆ, because there is no available oxygen. Because as temperature increases, solubility of gas in a liquid decreases. Gases escape ಆಗ್ತದೆ. So because of which it will be very difficult for them to breathe. So they prefer, going to cold region or cold water than being there in hot water. They don't come at the surface, you see. They will be always in the deep sea. Why? Because there it's much more cooler than at the surface. That is one application of Henry's law. One more you can talk about is, you talk about scuba divers. Scuba divers. Okay. You know that in scuba diving, when these people or these divers, when they move to deep sea, so there is a person, imagine. So they are swimming, imagine. All these are swimming in deep sea. Okay. And when these people swim, they actually carry oxygen cylinders and go down. So oxygen cylinders ittade avara hatra, athava gas cylinders ittade in order for them to breathe. Because underwater, you know what happens to pressure. Pressure increases. When pressure increases, solubility of a gas in a liquid increases. So pressure jasti adaga, whatever the gas is being taken by them will be easily soluble in the blood. Tumba oxygen hogi athava tumba air hogi dissolve ಆಗ್ತದೆ body ಒಳಗೆ, because air pressure is too high down there. Okay. But ಸಡನ್ಲಿ ಅವರು ಈಗ ಡೈವಿಂಗ್ ಎಲ್ಲ ಆಯ್ತು, ದೇ ಹ್ಯಾವ್ ಚೆಕ್ ಎವ್ರಿಥಿಂಗ್ ಅಂಡ್ ದೇ ಕಮ್ ಅಪ್, ಸಡನ್ಲಿ ಬರ್ತಾರೆ ಸರ್ಫೇಸ್ಗೆ. ಸರ್ಫೇಸ್ಗೆ ಬಂದಾಗ ಏನಾಗ್ತದೆ, ಆಟೋಮ್ಯಾಟಿಕಲಿ ವಾಟ್ ಎವರ್ ಗ್ಯಾಸಸ್ ವಿಚ್ ವರ್ ಡಿಸಾಲ್ವ್ಡ್ ಇನ್ ದ ಬ್ಲಡ್, ಅದು ಯಾವುದೇ ಗ್ಯಾಸ್ ಡಿಸಾಲ್ವ್ ಆಗಿದೆ ಬ್ಲಡ್ ಅಲ್ಲಿ, ಅದೆಲ್ಲ ಸಡನ್ಲಿ ಹೀಗೆ ಹೊರಗೆ ಬರ್ತದೆ. ವೈ? ಬಿಕಾಸ್ ಪ್ರೆಷರ್ ಡಿಕ್ರೀಸಸ್. ಪ್ರೆಷರ್ ಇನ್ಕ್ರೀಸ್ ಆದ್ರೆ ಎಲ್ಲ ಗ್ಯಾಸ್ ಅವರ ಬ್ಲಡ್ ಅಲ್ಲಿ ಸಾಲ್ಯುಬಲ್ ಆಗ್ತದೆ. ಬಟ್ ಪ್ರೆಷರ್ ಡಿಕ್ರೀಸ್ ಆದಾಗ ಏನಾಗ್ತದೆ, ಆಫ್ ಕೋರ್ಸ್ ದಟ್ ಗ್ಯಾಸ್ ಇಸ್ ಗೋಯಿಂಗ್ ಟು ಕಮ್ ಅಪ್ ಅಗೇನ್. When suddenly these people come to the surface, ಇಲ್ಲಿ ಮೇಲೆಗೆ ಬಂದಾಗ ಈ ಗ್ಯಾಸ್ ಅವ್ರು ಏನು ಎಕ್ಸೇಲ್ ಮಾಡ್ತಾರೆ, ಬಿಕಾಸ್ ವಿಚ್ ನೈಟ್ರೋಜನ್ ಕಂಟೆಂಟ್ ಇರತ್ತಲ್ಲ, ಅದೇ ಸಿಲಿಂಡರ್ ಅಲ್ಲಿ ನೈಟ್ರೋಜನ್ ಕಂಟೆಂಟ್ ಇದ್ದದ್ದು ಅವರ ಬ್ಲಡ್ ಇಂದ ಸಡನ್ಲಿ ಹೊರಗೆ ಬಂದಾಗ, ಬಿಕಾಸ್ ವೆನ್ ದ ಪ್ರೆಷರ್ ಡಿಕ್ರೀಸ್ ದಟ್ ಏರ್ ಹ್ಯಾಸ್ ಟು ಕಮ್ ಔಟ್ ಆಫ್ ಯೋರ್ ಬ್ಲಡ್, ನೈಟ್ರೋಜನ್ ಗ್ಯಾಸ್ ಹೊರಗೆ ಬರುವಾಗ you'll find a lot of pain in your body, neck, it's like joint is going to pain completely because of the nitrogen gas being evolving suddenly from your blood. And that situation or that kind of pain is called bends. Bends is what we call. Very, very important. They may ask you, in scuba diving, there is evolution of nitrogen gas, which causes a painful condition that is called bends due to the decrease in pressure. Diving deep sea ali ಮಾಡಿದಾಗ increase in pressure, but ಅದೇ ಮೇಲೆ ಬಂದಾಗ decrease in pressure, because of which nitrogen gas gets evolved, which causes a painful condition that is called bends. ಈಗ ಏನ್ ಮಾಡ್ತೇವೆ, ಇದು ಪೇನ್ಫುಲ್ ಕಂಡೀಷನ್ ಬರಬಾರ್ದು. ಇಟ್ ಇಸ್ ಟೂ ಮಚ್ ಟು ಬೇರ್ ಫಾರ್ ದೆಮ್. ಸೊ ವಾಟ್ ಹ್ಯಾಪನ್ಸ್ ಇಸ್, ವೆನ್ ಎವರ್ ದೇ ಗೋ ಇನ್ ಟು ದ ಡೀಪ್ ಸಿ ಓನ್ಲಿ, ಬಿಫೋರ್ ದೇ ಫಿಲ್ ದೀಸ್ ಸಿಲಿಂಡರ್ಸ್ ವಿತ್ ಏರ್, ಈ ಸಿಲಿಂಡರ್ಸ್ ಹಾಕುವ ಮುಂಚೆನೆ ಇನ್ಸ್ಟೆಡ್ ಆಫ್ ನೈಟ್ರೋಜನ್ ಬೀಯಿಂಗ್ ಡಿಸಾಲ್ವ್, ಆ ನೈಟ್ರೋಜನ್ ಹೋಗಿ ಡಿಸಾಲ್ವ್ ಆಗಬಹುದಲ್ಲ, ಅದಕ್ಕೆ ಈ ಏರ್ ಅನ್ನು ಅವರು ಡೈಲ್ಯೂಟ್ ಮಾಡ್ತಾರೆ. Diluted with helium, children. Because when you compare it to nitrogen and helium, helium is less soluble in blood. So helium ಹೋಗುವ ಚಾನ್ಸ್ ಇಲ್ಲ, more amount of oxygen ನಿಲ್ತದೆ ಬ್ಲಡ್ ಅಲ್ಲಿ. ನೈಟ್ರೋಜನ್ ಹೋಗುವ ಚಾನ್ಸ್ ಇಲ್ಲ, because they have diluted it with the helium. So helium is said to be less soluble in blood. ಅವರ less soluble ಆಗ್ಬೇಕಿದ್ರೆ ಅವರ Henry's constant value will be ಜಾಸ್ತಿ, ಕರೆಕ್ಟಾ? ಸೊ ಲೆಸ್ ಸಾಲ್ಯುಬಲ್ ಇನ್ ಬ್ಲಡ್, ದಟ್ಸ್ ವೈ ಇಟ್ ಡಸ್ ನಾಟ್ ಕಾಸ್ ದಟ್ ಪೇನ್ಫುಲ್ ಕಂಡೀಷನ್. ಯಾರಿಂದ ಅದು ಪೇನ್ಫುಲ್ ಕಂಡೀಷನ್? ನೈಟ್ರೋಜನ್ ಗ್ಯಾಸ್ ಇದ್ರೆ ಅದು ಪೇನ್ಫುಲ್ ಕಂಡೀಷನ್. ಬಟ್ ಇಲ್ಲಿ ಹೀಲಿಯಂ ಅನ್ನು ಮಿಕ್ಸ್ ಮಾಡಿದ್ರೆ ಅಷ್ಟು ಪೇನ್ ಆಗಲ್ಲ, ಬಿಕಾಸ್ ಇಟ್ಸ್ ನಾಟ್ ಗೋಯಿಂಗ್ ಟು ಡಿಸಾಲ್ವ್ ಇನ್ ಯೋರ್ ಬ್ಲಡ್ ಅಂಡ್ ಸಡನ್ಲಿ ರಶ್ ಔಟ್. Okay, that is one application in Henry's law. And the last one that you have is regarding higher altitudes, mountain climbers. Okay, ಈ mountain climbers ಮೆಲ್ಲ ಹತ್ತುತ್ತಾರೆ, they go up to the peak. ಈಗ ಪೀಕಿಗೆ ಹೋಗಿ ನಿಂತಾಗ, ಈಗ ಕ್ಲೈಂಬ್ ಮಾಡುವಾಗ, that air pressure is very less. Air pressure is less when you go to the top. But I told you, scuba diving, deep sea, air pressure will be more, too much gas can be soluble. But air pressure kammi iddaga, the gas, the oxygen is not going to dissolve in your blood completely, because of which you won't be able to breathe. You will have that fainting situation. You feel like vomiting. You can't breathe. The head is going to ache. And that condition where you don't have enough oxygen to breathe is called anoxia. Anoxia. Okay, this question also they may ask you, what is that pain, or what is that condition wherein you won't be able to breathe enough oxygen at higher altitudes. Higher altitudes andaga, you should know about that disease, that is anoxia. Okay, but when it comes to scuba diving, that painful condition is called bends. Idella ಗೊತ್ತಿರಬೇಕು. So because of which ಈಗ higher altitudes ಅಲ್ಲಿ ನಮಗೆ breathe ಮಾಡ್ಲಿಕ್ಕೆ ಆಗ್ಲಿಲ್ಲ, then what is the only option? We carry oxygen cylinders, put a mask and go, so that you have enough oxygen to breathe. ಅಲ್ಲಿ ನಮಗೆ ಇರಲ್ಲ enough oxygen. Why? Because pressure decreases. ನಮಗೆ ಇಲ್ಲಿ pressure ಮತ್ತೆ gas, ಅದು ನಮಗೆ main important application of Henry's law. So this was about the application of Henry's law. Next we have solubility of liquid in liquid. But before that, let me just brush up once again for whatever we have studied till now. Once again from the first till here, because you need to understand the topic rather than just looking at it and So starting from, again, I'll be brushing up. So you studied what is a solution, then you studied what is solute, then you studied what is solvent, correct? Solvent is the one in large quantity, solute is the one in lesser quantity. Then you went to types of solutions, right? There you found solid solutions, gaseous solutions, liquid solutions. Then you went to the concentration terms, nodidra. Concentration terms, Ali, once again, which and all you studied. One was mass percentage, correct? Then you studied what is volume percentage. Then you studied what is mass. by volume percentage, correct? Then you studied ppm, parts per million, NPD, I hope so. Parts per million is number of parts of a particular component into 10 to the power 6 divided by total number of components. Then you had molarity. Then you studied called molality, right? And then you also studied something called mole fraction, all these were concentration terms. Once again, whenever these terms are being given, it's your duty to, automatically recite the formulas or remember the formulas, then only it's going to work. Next, you studied something called solubility, right? In that solubility, you studied something called, first one was solubility of solid in liquid you studied, correct? Which example did I take, children? Here I've taken an example of salt and water. I hope you remember. Their effect of pressure won't be there because it's a solid, but effect of temperature, two things were there. One is delta H is equal to positive. It is endothermic reaction, and delta H is equal to negative, where it is exothermic reaction. Endothermic reaction, again, as you increase the temperature, solubility increases, whereas for exothermic reaction, solubility decreases. This was the thing. And then second one, you went to solubility of a gas in liquid, I guess. Solubility of a gas in liquid. There you went to, first one was effect of pressure. Effect of pressure is given by something called Henry's law. Hope you remember this thing also, statement also. The partial vapor pressure is directly proportional to the mole fraction of the solution, mole fraction of the gas present in the solution. So Henry's law expression was given as P is equal to KH into X. I told you who are friends here. P is friends with X, P is friends with solubility, and X, whereas KH is friends with whom? Temperature. It is studied by looking at the temperature. So this is the enemy with whom? Pressure, solubility, and mole fraction. All of them, it is in enemy. So as KH value increases, solubility always decreases. That is what you studied. Then you studied the different values for Henry's law. Then you went to the applications of Henry's law. There you studied what is called bends. Then you studied what is called anoxia. Then you studied where is it used, aerated drinks or soft drinks you use. Then one more is that aquatic animals, they prefer cold water than hot water. Why? Because as temperature increases, the gas dissolved in a liquid will, solubility will decrease. So much we have covered up till now. Now we move on to solubility of liquid in liquid. Okay. Solubility of liquid in liquid. Yes, here we have. So solubility of, this will be third one. First one was solubility of solid in liquid. Second one was solubility of gas in liquid. Then you go to solubility of liquid in liquid. Okay. So when you talk about solubility of liquid in liquid, you will be having a condition that is, these are volatile liquids. Volatile liquids. One condition will take, then I'll tell you. Volatile liquids. What do you mean by volatile in nature? Volatile andre, ನೀವು sanitizer ಅನ್ನ apply ಮಾಡ್ತೀರಾ, correct? After some time you see that it just gets evaporate. Your hands becomes dry. So such type of solutions you call it volatile. Acetone, nail polish remover ಹಾಕ್ತೀರಾ in order to clean the nail paint. You see that also gets dried up very fast. So, whichever is able to evaporate and turn into which state, evaporate andre ಯಾವ state in the ಯಾವ state it is from the liquid to gas, correct? Inta one solutions, you call it volatile solutions. At the room temperature, if it is able to change its state from liquid to gas, then you call it volatile solution. Easily volatile. Okay. But water is also said to be volatile, but it is quite less volatile when you compare to acetone and sanitizer, maybe alcohol. Okay. So let me just take an example of acetone, that is a volatile liquid, and another one is alcohol, I think. Okay. So acetone and alcohol, you have two volatile liquids. Now we are talking about liquid and liquid. Specifically, it is two volatile liquids. So I have dissolved acetone and alcohol together. All right. Now ಈಗ ಇವರಿಬ್ರು ವಾಲಟೈಲ್ ಇನ್ ನೇಚರ್ ಅಂದ್ರೆ ಏನು? They will get converted to vapor state. ಕರೆಕ್ಟಾ? Of course, acetone vapors ಇರುತ್ತೆ, alcohol vapors ಇರುತ್ತೆ. Now, those vapors are in which form? You said gaseous form. ಇವುಗಳೆಲ್ಲ gaseous form ಅಲ್ಲಿ ಇರುತ್ತೆ. And you know that gases, they don't stay in one place. They of course collide with each other. They hit each other, because of which they exert certain pressure. Now, where are the gases here? No, on the top, no, on the surface, no, correct? And these collide with each other. These will hit, this will hit each other, correct? Because of which they exert pressure, and that pressure exerted by these two volatile liquids is called vapor pressure. Vapor pressure. Where is it exerting? On the surface of the liquid. Understood? So that time it was in Henry's law, it was partial pressure. Right now it is something called vapor pressure. The pressure exerted by the vapors, which is formed by which type of liquids? Volatile liquids. ಅಂದ್ರೆ ಯಾವುದೇ ಬೇಗ ಡ್ರೈ ಆಗ್ತದೆ ಅದಕ್ಕೆ ಹೇಳುದು volatile liquids. ಅದಕ್ಕೆ ಹೇಳುದು vapor pressure. Pressure exerted by the vapors onto a top of the liquid is called vapor pressure. This is understood. Now, in order to explain this, that is the concept of vapor pressure, there comes a person named Raoult's law. Like how Henry's law talks about solubility of a gas in liquid, this guy talks about solubility of a liquid in liquid and its relation with respect to vapor pressure. Okay. So Raoult's law, let us see what does Raoult's law talk about. See here. Just look into the second point here. It states that for a solution of two volatile liquids, just now we took the example of volatile liquids only, alcohol and acetone, ಮತ್ತೆ dissolve ಮಾಡಿದ್ವಿ. The partial vapor pressure of each component, andre, of course, acetone vapors ಆಗ್ತಾ ಉಂಟು. Of course, they exert a partial vapor pressure. Alcohol vapors ಆಗ್ತಾ ಇದೆ. Of course, they also apply certain partial vapor pressure. So partial pressure of each component in the solution is directly proportional to mole fraction present in the solution. ಅಂದ್ರೆ ನಾನು ಎಷ್ಟೇ ಆಲ್ಕೋಹಾಲ್ ಕಂಟೆಂಟ್ ತೆಗೆದಿದ್ದೇನೆ ಅಷ್ಟೇ ವೇಪರ್ಸ್ ಇಲ್ಲಿ ಬರೋದು. ಎಷ್ಟೇ ಎಸಿಟೋನ್ ಕಂಟೆಂಟ್ ತೆಗೆಯೋದು ಅಷ್ಟೇ ವೇಪರ್ಸ್ ಇಲ್ಲಿ ಬರುತ್ತೆ. ಸೊ ಪಾರ್ಷಿಯಲ್ ವೇಪರ್ ಪ್ರೆಷರ್ ಇಸ್ ಡೈರೆಕ್ಟ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್ ಟು ಮೋಲ್ ಫ್ರಾಕ್ಷನ್ ಆಫ್ ದ ಸೊಲ್ಯೂಷನ್. ನಾನು ಎಷ್ಟೇ ವಾಲಟೈಲ್ ಲಿಕ್ವಿಡ್ಸ್ ತೆಗಿದ್ದಾನೆ ಅಷ್ಟೇ ವೇಪರ್ ಪ್ರೆಷರ್ ಅಲ್ಲಿ ಎಕ್ಸರ್ಟ್ ಆಗ್ತದೆ. ದಟ್ಸ್ ಆಲ್. ಓಕೆ. So that is given by the statement named Henry's law. So, you know, it's basically you have to understand the example, then only you can apply the law. It states that for a solution of two volatile liquids, acetone and alcohol, the partial vapor pressure of each component of the solution is directly proportional to mole fraction. How much ever is air in the beaker, so much only vapor pressure can be exerted. That is what is told by Raoult's law. But, this you'll have to connect it with, something that you studied in first year, that is Dalton's law of partial pressure. This was there in a chapter named States of Matter. So Dalton's law of partial pressure states that. Dalton's law of partial pressure states that. Okay. The total pressure exerted by two liquids or two components will be the sum of partial pressure of one component plus partial pressure of second component. Or it's basically the sum of all the components is what you say. Illi sum andre ನಾನು ಯಾರ್ದೆಲ್ಲ ತೆಗೆದಿದ್ದೇನೆ ಇಲ್ಲಿ ಆಲ್ಕೋಹಾಲ್ ಮತ್ತೆ ಎಸಿಟೋನ್. So other vapor pressure plus alcohol vapor pressure will be equal to the total vapor pressure. So Raoult's also makes use of this only. So P total for acetone and alcohol, okay, both the vapor pressure will be calculated as P of acetone under P1 plus P of alcohol, pressure of alcohol. That you call it partial vapor pressure of acetone, partial vapor pressure of alcohol. I told you that time also partial and the individual pressures and the use model. Or this can be also given as, they told that partial vapor pressure is directly proportional to the mole fraction of the solution. So how much ever they exert in their pure form. Now. When I stress on this word, please understand. Okay. ಈಗ P1 andre, it is partial pressure of acetone ಅಂತ ಹೇಳ್ತೇವೆ. So P1 not andre, the partial pressure of acetone only, but in its pure form. ಖಾಲಿ ನಾನು acetone ತೆಗೆದಿದ್ರೆ, ಇನ್ನೊಂದು ಬೀಕರಲ್ಲಿ ಖಾಲಿ ಆಲ್ಕೋಹಾಲ್ ತೆಗೆದಿದ್ರೆ, ಅವರ ಓನ್ partial pressure ಏನಿದೆ, that will be, now you have added both, no? That will be equal to some more. So P1 is equal to P1 naught. P1 naught andre pure form and its mole fraction. ಅಂತ ಹೇಳಿದ್ರೆ alcohol is the pure vapor pressure. I'm sorry, P2 naught of vapor pressure into X2. Now they said according to Dalton's law, it is a sum of both the partial vapor pressure. So what you do is P1 naught X1 plus P2 naught X2 will be the formula. Okay. P1 naught X1 plus P2 naught X2. This is the formula for Raoult's law of two volatile solutions. Once again, I'll tell. One second. So here we have. So this was nothing but Raoult's law. According to Raoult's law, P total is equal to P1 naught x1 plus P2 naught x2. This is derived from what? Dalton's law. Dalton's law was P total is equal to P1 plus P2. E P1 andre P1 naught pure form into x1 plus P2 naught andre P2 naught andre pure form into x2. Mole fraction andre x1 and x2. Alcohol mate acetone. That will give you the total pressure of a particular volatile liquid solution. Or you can also write this as P1 naught into x1 plus P2 naught into x2 annu x1 terms alli hege baryodu children, like I told you that time, right? x1 plus x2 will be equal to 1. So x2, how do you write? 1 minus x1, correct? Idannu hagu baribodu, that is 1 minus x1. Like this also you can write. Suppose problems and all, if they have given you only 1 mole fraction, then you convert in this form and write down. Okay, or if you want a simplified form, then it will be P1 naught x1 plus P2 naught minus P2 naught. I'm just going to multiply inside. Okay, so you can also put this as P1 naught minus P2 naught into x1 plus P2 naught. In that way also you can write, this way. P1 naught minus P2 naught, because those both are common, into x1 plus P2 naught. This way also you can write. Hope it is fine. Yes. So this was all about Raoult's law. Raoult's law statement with the Raoult's law's expression is very, very important. Okay. Again, once again, you will see the statement. It states that for a solution of volatile liquids, the partial vapor pressure of each component of the solution is directly proportional to its mole fraction present in the solution, when P total will be equal to P1 naught x1 plus P2 naught x2. Please be careful with respect to this also. P1 naught and P2 naught are vapor pressure of pure components. Please make a note of this. Not anta helidre, there will be pure components of 1 and 2 respectively at the same temperature. Then we apply Dalton's law. Please have an idea about this also. Dalton's law of partial pressure is a gas law which states that total pressure is equal to the sum of the individual partial pressure exerted by the gas in the mixture. Individually calculate madidre, you get the sum of all the partial pressure. That's all it says. Okay. Next, we have just a variation based on this Raoult's law for solid liquid solutions. It states that solid liquid andre, you have added a liquid. Adikke one non-volatile solute. Non-volatile solute, maybe salt only I take. Non-volatile solute add. Okay. So it states that relative lowering of vapor pressure of a solution containing a non-volatile solute is directly proportional to mole fraction of the solute. Okay. Now listen properly. So imagine illi nanu kali maybe a volatile liquid tegididde. Okay. Volatile liquid. Let's take an example of water only. Yeah, it is volatile. Takes a lot of time in order to evaporate, but let's take an example of water only. So it's going to evaporate like this. Okay. Evaporate agi yava state alli niltade? Gaseous phase. And you know that these gaseous molecules, they don't stand like that only. They collide with each other, They collide with each other, and of course they exert what? Pressure. And that pressure is called what? Vapor pressure is what you say. Vapor pressure anta ಹೇಳ್ತಾರೆ. ಈಗ ಇದು ತೊಂದ್ರೆ ಇಲ್ಲ, ಖಾಲಿ ಒಂದೇ ಕಾಂಪೊನೆಂಟ್ ಇದ್ದು, ಒಂದೇ ಲಿಕ್ವಿಡ್ ಇದ್ದದ್ದು, ಒಂದೇ ನೀರ್ ಇದ್ದದ್ದು. Okay, that is becoming pressure and it is exerting vapor pressure. ತೊಂದ್ರೆನೇ ಇರ್ಲಿಲ್ಲ first. Now I'm going to add some uppadra here. Okay, what is that? Salt I'm going to add. ಸ್ವಲ್ಪ disturbance ಮಾಡುವ. Okay, so I'm going to add a little bit of salt. ಈಗ tell me, will the vapors be generated easily or will the vapors be generated in a very difficult manner? Vari kashta ideya vapors agಲಿಕ್ಕೆ, ಅಥವಾ ಮುಂಚೆ ತರಾನೇ vapors ಆರಾಮ್ಸೆ escape ಆಗ್ತಿದೆಯಾ? Of course, the vapors formed will decrease. Why? Because you have added something in order to block those water molecules go and evaporate. Correct? ಇಲ್ಲಿ ನೀವೆಲ್ಲ ಬ್ಲಾಕ್ ಮಾಡಿದ್ರಿ ಸ್ಪೇಸಸ್. ಇಂಥದನ್ನ ಆಡ್ ಮಾಡಿ, ಸಾಲ್ಟ್ ಅನ್ನ ಆಡ್ ಮಾಡಿ, ಎಲ್ಲ ಬ್ಲಾಕ್ ಆಯ್ತು ಸ್ಪೇಸ್. ಅದಕ್ಕೆ ಏನಾಗ್ತದೆ, ಈಗ ವಾಟರ್ ಅದು ಇವ್ಯಾಪರೇಟ್ ಆಗ್ತದ? ಇಲ್ಲ, ಇಟ್ ಇಸ್ ನಾಟ್ ಏಬಲ್ ಟು ಇವ್ಯಾಪರೇಟ್, ರೈಟ್? ಸೊ ವೇಪರ್ ಪ್ರೆಷರ್, ವೇಪರ್ಸೇ ಇಲ್ಲ, ಹಾಗಾದ್ರೆ ವೇಪರ್ ಪ್ರೆಷರ್ ಎಲ್ಲಿಂದ ಬರ್ತದೆ? ಇಲ್ಲ, ಇರಲ್ಲ. ಸೊ ವೇಪರ್ ಪ್ರೆಷರ್ ಆಲ್ವೇಸ್ ಡಿಕ್ರೀಸಸ್ whenever you add some amount of non-volatile solute. Why did I use the word non-volatile solute? Non-volatile andre avugalu evaporate agudiಲ್ಲ. Non-volatile ಮಾಡಿದ್ರೆ ವೇಪರ್ ಪ್ರೆಷರ್ ಆಗ್ತದೆ ಡಿಕ್ರೀಸ್ ಆಗ್ತದೆ. ಓಕೆ, only if you have two volatile liquids aramse escaping into vapors, then there will be vapor pressure generated. But when you have a solute added, non-volatile solute added into the volatile solvent, then the vapor pressure decreases because you have blocked the ways from which it can escape into a gaseous form. So before and after compare madidre vapor pressure has decreased is what we say. So just see here, very, very important law, that is Raoult's law for solid liquid solutions. Once again, you try understanding relative lowering before and after. You compare it with before and after. So before ಏನಿತ್ತು vapor pressure ಜಾಸ್ತಿ ಇತ್ತು, ಖಾಲಿ ನೀರಿತ್ತು. But then when you added salt, what happened is vapor pressure decreased. So relative lowering in vapor pressure of the solution containing a non-volatile solute, ಉಪ್ಪು ಹಾಕಿದ್ದೀರಾ, is equal to the mole fraction of the solute. ನೀವು ಯಾರ ಮೇಲೆ ಅದು ದೂರ ಹಾಕ್ಬೇಕು, ಯಾರ ಮೇಲೆ ಬ್ಲೇಮ್ ಮಾಡಬೇಕು? It is all because of the salt particles you added. ಅಷ್ಟೋ ತನಕ it was escaping to vapors, no problem. But then just because you added that solute, no, the vapor is not able to escape. So vapor pressure decrease. That's why it says relative vapor pressure decrease. That's why relative lowering of vapor pressure of a solution containing a non-volatile solute is equal to the mole fraction of the solute. So something like this, you can give the expression. 1 minute. One expression will give. Idu Raoult's law under alliye, it will be a variety. Okay. First ಹೇಳಿದು ನಾವು volatile solutions, ಮತ್ತೆ ಇನ್ನೊಂದು solid in a liquid. ಅದಕ್ಕೆ ಹೇಳುದು Raoult's law of relative lowering of vapor pressure. I will just call it in a short form, that is RLVP ಅಂತ ಕರಿತೇನೆ. Okay, RLVP, relative lowering of vapor pressure is what we call. Now, last on the expression, that is P1 naught. ಈಗ I told you, not ಅಂದ್ರೆ ಏನ್ ನೆನಪಿಡ್ಬೇಕು, ಅದು not ಅಂದ್ರೆ it is pure form, ಖಾಲಿ ನೀರಿದ್ದ ಫಾರ್ಮ್. ನೀವೇನ್ ಮಾಡಿದ್ರ, ಆಡ್ ಮಾಡಿದ್ರ, ಅದಕ್ಕೆ ಸಾಲ್ಟ್ ಆಡ್ ಮಾಡಿದ್ರ, ಆಗ ವೇಪರ್ ಪ್ರೆಷರ್ ಏನಾಯ್ತು, ಡಿಕ್ರೀಸ್ ಆಯ್ತು. ಆ ಡಿಕ್ರೀಸ್ ಆದ ವೇಪರ್ ಪ್ರೆಷರ್ ಅನ್ನು ನಾನು P1 ಅಂತ ಬರೀತೇನೆ. Initially ಜಾಸ್ತಿ ವೇಪರ್ ಪ್ರೆಷರ್ ಇತ್ತು, just because you added salt, something happened there, vapor pressure decreased. That's why change in that vapor pressure, I put it as P1. Not under pure form. So relative ಅಲ್ಲ, you're comparing it with before. ಇದು after part. P1 naught minus P1 decrease ಆಯ್ತು when you compare it to the previous part. That's why it's called this together term is called RLVP, relative lowering of vapor pressure. Please remember, P1 naught minus P1 divided by P1 naught is equal to, ಯಾರ ಮೇಲೆ ದೂರ ಹಾಕ್ಬೇಕು ನಾನು, ಸಾಲ್ಟ್ ಅಲ್ಲ, salt ಅನ್ನು let me take it as mole fraction of the salt ಅನ್ನು ನಾನು 2 ಅಂತ ಹಾಕ್ತೇನೆ. You know, this is just my idea in order to remember, just a trick to remember. ನಾವು ಹೇಳ್ತೇವೆ salt ಅಂದ್ರೆ ಏನದು, solute, ಕರೆಕ್ಟಾ? solute ನಾವು ಹೇಳುವಾಗನೆ, ಅದನ್ನ ಪ್ರೊನೌನ್ಸ್ ಮಾಡುವಾಗನೆ ಇಟ್ಸ್ ಲೈಕ್ solute. So number will be always 2. ಅದರ ನಂಬರ್, solute the number always 2. solvent will be always 1. ಈಗ ನಾನು x1 ಅಂತ ಹಾಕಿದ್ರೆ ಅದು ಯಾರ್ದು, solvent. 2 ಅಂತ ಹಾಕಿದ್ರೆ it is always solute. 2, remember like that. So when it comes to problems, you don't have any confusion. 2 ಅಂತ ಹೇಳಿದ್ರೆ it is always solute. ಸಣ್ಣ ಮಾತ್ರದಲ್ಲಿ ಹಾಕಿದ್ದು. solvent ಅಂತ ಹೇಳಿದ್ರೆ 1 ಅಂತ ನೆನಪಿಡಿ. So those numbers and all you should remember. But this anyway is not required for now. Which one? You know, x1. But you should know that relative lowering of vapor pressure, ಎಲ್ಲದನ್ನು ನಾವು ದೂರ ಹಾಕಿದ್ದು ಯಾರ ಮೇಲೆ, ಸಾಲ್ಟ್ ಇದ್ ಮೇಲೆ. ಸಾಲ್ಟ್ ಇದು ಮೋಲ್ ಫ್ರಾಕ್ಷನ್ ಮೇಲೆ, ಬಿಕಾಸ್ ವಿ ನೀಡ್ ಅ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಟರ್ಮ್ ಅಲ್ಲ. ಸೊ x2 ಅಂತ ಹಾಕಿದ್ವಿ. ಸೊ P1 naught minus P1 divided by P1 naught is equal to x2. That you have to remember. Okay. This can be also written as x2 ಅಂದ್ರೆ ಏನು children? It is n2 divided by n1 plus n2 ಅಲ್ಲ. But as it is a dilute solution ಅಲ್ಲಿ ನಿಮ್ಗೆ ಜಾಸ್ತಿ ನೀರಿರುತ್ತೆ, ಕಮ್ಮಿ ಸಾಲ್ಟ್ ಇರುತ್ತೆ. So what you can do is this, you can ignore or make it negligible. For a dilute solution only, please remember the condition. So it will be N2 by N1. N2 andre eno, number of moles. Number of moles will be equal to mass by molar mass. Mass by molar mass divided by mass by molar mass. Idan mele tekondu hoga. So W2 M1 divided by M2 into W1. This can be also given. Idu illinda derive ಮಾಡಿದ್ದು. X2 is equal to N2 divided by N1 plus N2. For a dilute solution, N2 is negligible. So N2 by N1. N2 ಅಂದ್ರೆ number of moles ಅಂದ್ರೆ mass by molar mass. Mass ಅನ್ನು ಕೊಡುದು W, molar mass ಅನ್ನು ಕೊಡುದು M, capital letter M divided by W, again mass, molar mass M will be equal to, ಹೀಗೆ ಹಾಕಿ ಕೊಟ್ಟದ್ದು. Okay, so I guess the time is up. Let me just glance through once again, just a rough point, then I will be continuing it tomorrow for you. Just a minute. Okay, we have 1 minute left. All right, so solution. Then we studied solvent, solute, that and all you know. Then you studied types of solutions. Then you went to concentration terms, 7 formulas you should know. Then you went to solubility of a gas in liquid, that is Henry's law. Then solubility of solid in liquid, their endothermic and exothermic, that you should know. Endothermic and exothermic. Henry's law expression you saw, that is P is equal to KH into X. Then application of Henry's law, bends, enox, adala ನೆನಪಿಡ್ಬೇಕು. Then you went to solubility of liquid in liquid, ಅಲ್ಲಿ Raoult's law ಬರುತ್ತೆ. ಅಲ್ಲಿ vapor pressure the formula, that is P total is equal to P1 naught x1 plus P2 naught x2. ಇದೊಂದು ನೆನಪಿಡ್ಬೇಕು. Then you went to Raoult's law only for solid in liquid. ಅಲ್ಲಿ ಬರೋದು relative lowering of vapor pressure. Vapor pressure lowering ಆಗ್ತಿದೆ. That's why you derive the formula, that is P1 naught minus P1 divided by P1 naught is equal to x2. ಅಥವಾ you can also write it as W2 M1 divided by M2 into W1. So much we have covered up. So much we have covered up. So we shall see in the next class. If any doubts, you can, put up the messages or in whatever ways you are comfortable with. We can explain it once again. Yes. So thank you for the cooperation. Thank you for the listening. We shall wind up the class.